if I kept doing odd math lives, I would eventually like reach like a audience that understand odd maths. For sure.
I agree. Yeah, and I
You
feel
kind of
like.
like, yeah,
Hmm?
yeah. Talk to me. You feel
No,
like,
continue. Sorry.
no, I forgot what I was gonna say.
Oh, me too. This is awkward.
Um, it's like when you're filtering, like if you pour water in and you pour in water into a cup with coffee, right?
Yeah.
If you pour water in the cup long enough, then the only thing that remains is just water. If you understand what I'm saying.
Ah, I see. So, like, if they keep doing it, they'll eventually, develop or foster a love for it, you know?
Yeah, suppose
Yeah.
so.
Yes, sir.
And like people will leave, but the people that do hard maths will stay. That makes sense.
Yeah. Because I feel like not enough people do, like, add math lives.
Yeah. I mean, Chris from Adaptation does it. He's really good, but
Yeah.
I feel bad for him. He doesn't get the attention he deserves. He's really good. He's really good.
Oh,
I
hopefully he
rate
does
Chris.
soon. Okay.
So let's begin. So I don't want to record this session. So this is a live. It go automatically go up.
Oh, yeah, yeah.
All right. So implicit differentiation.
How fun.
Now you differentiate something implicitly when you don't have a direct relationship. And what I'm saying is like something is not the subject of the formula. So you have to infer how one variable is changing with respect to the other one. And I'll show you what I mean. But before we do this, I want to just revisit our good friend chain rule. Right? I want to revisit chain rule. So guys, let's just say we had a function L and L was equal to 5x plus 8 to the power 9. Tell me, Jenna, how would you work that out? Let's look at the full version first. Tell me, Jenna, how would you work that out? What's causing trouble there, Jenna? What's causing trouble?
The 5x plus 8.
Exactly. So we could say, let what?
Let u equals 5x plus 8.
Good. And,
And
then we could say that L is now equal to what?
the u to the power 9.
Exactly. Then you would say du dx is equal to what?
5.
Right? And then, you go, what you say?
dl dx. No,
Nah.
yeah.
Take your time. Take your time. I mean, dl.
dl du.
Yeah, dl du. And now equal to what?
9 to the power 8. 9u to the power 8.
And so when you're finding, okay, let's look at the original question. The original question was L is equal to 5x plus 8 to the power 9. So you wanted to differentiate the function L with respect to x. So when you're writing your answer now, what's the answer going to look like?
Is
So Jenna, yeah, someone. Let me see if you're correct.
is dl du
No,
is
so what function do you have here? You have a function for L in terms of
9?
exactly.
No, in terms
no,
of
no, in terms of x.
Oh, okay.
So you're differentiating what with respect to what? What is changing with respect to what?
L is changing with respect to x.
Yeah, so when you change x, like if you put, okay, like let's just say you put in 1 for x, right? And you get like a value for L.
Yes, sir.
Yeah, this is pure maths. This is pure maths. Well, abridging, odd maths, and pure maths. I do pure maths, by the way. Yeah. So if you put in 1 into this, would you get a specific value for L?
Yes, sir.
If you replace x with 2, would you get the same value for L or a different value for L?
A different value
Exactly. So L is changing with respect
to x.
Exactly. That makes sense, right? Because when you change x, L changing. So L is dependent on x. Does that make sense? L is dependent on x.
Yes, sir.
Okay. So what I want to find, what did I want to find then? What did I want to find?
X.
if I want to differentiate this, what am I really finding?
You find L. Wait, no.
Nah. So, okay, remember, when we differentiate, we're trying to figure out how one thing changes with respect to the other thing. So, what is changing with respect to what in this equation?
X is changing with respect to L.
No, L is changing with respect to X.
Okay.
Because L is dependent on X. Like, if you plug in a value for X, like let's just say plug in 0, let's just say plug in 1, you'll notice that different values for X will give you different values for L.
Okay.
Let me show you an example. If someone confused.
Yeah.
If I tell you X was 1, L would be equal to 5 by 1 plus 8 to the power 9. Alright, so that would be 13 to the power 9. Right, and I'll show you the calculator in the calculator.
Yes, sir.
If I told you X was 2, then I would replace X with what?
2.
So that would be 5 by 2 is 10, 10 plus 8 is 18 to the power 9. Did I get the same value for L or a different value for L?
Different values.
Different value for L. So what is changing with respect to what there?
L is changing with respect to X.
Exactly, so write that for me. How would I write that?
So 5
So
over.
nah. So I explain. If I say u is equal to 5x plus 8, then du dx means I'm differentiating the function u with respect to x. So you just told me that L is changing with respect to what?
To X.
So how would I write that in notation form?
L equals X.
Nah.
Or dl du equals X.
Nah. Okay, I get it. So what is changing with respect to what there?
L is changing with respect to X.
Good. L is changing with respect to x. So how do you write that in derivative notation?
Oh, dl dx.
Yeah, dl dx.
Oh,
Yeah. So let me explain this, right? Typically, L is the output and X is the input. So the output would change with respect to the
with respect to the input.
exactly, because you saw when I change the value for X, like when I plugged in different values for X, what happened?
The L would change. The answer would change.
Exactly. So we're trying to find the LDX there, right? We're trying
Yes,
to
sir.
figure out the rate at which L changes with respect to X.
Okay.
You understand now? Now.
Yes, sir.
So how would I find the LDX? Well, we had to use the chain rule. So if I use the chain rule, how would I find the LDX?
So du dx multiplied by dl du.
Now see, so du dx multiply by dl du, will that work?
Yes, sir.
Yeah, it would work, right? Because the du's would cancel off, and that would give me dl dx. That make sense?
Yes. Yes, sir.
Now, just for like the sake of like a standard, I'll put dl first, because we are accustomed saying like dl will go in numerator,
Mm-hmm.
and then dx will go in the denominator. So I'm gonna stick to the standard for now.
Okay.
So, what is dl du?
dl du. 9 to the power 9u to the power 8
Multiply by.
multiplied by 5.
Now I want you all to realize something carefully. Now you just always hear me saying that you just use chain rule anytime you have composite functions, like a function and a function. I don't think I'll ever understand what I mean. It's
Partially, not completely.
okay. So like 5x plus 8 to the power 9. Couldn't that be expressed as u to the power 9?
Yes, sir.
Right? So I would say that this is the outer function, and what is the function that's going inside the u? What's that function going inside the u?
5x plus 8.
Exactly. So u to the power 9 is the outer function, and what's going into u?
Is 5x plus 8, so that's the inner function.
Yeah. So
Oh.
that was like the whole concept. So like this u to the power 9 you see in here, that's actually the outer function.
Oh.
This whole thing is the outer function. So We're raising whatever you put in to the power 9. Can you see that? Like, whatever you put in, you're raising that to the power 9. So
Yes,
this is
sir.
the outer function. And Jenna, what is the inner function?
5x plus 8.
And that would be replaced with what?
5.
Nah, okay.
Wait.
Let me take a step back, right? I'm right in that form that you would probably perceive better. So I'm gonna put u in brackets to the power 9. Alright? So Jenna, when I say the outer function, I'm talking about this whole thing over here. So the outer function refers to what I'm doing to what's on the inside. So like, Jenna, what's on the inside there?
U.
Right. U could be a function in terms of what? Look at everything on the screen. U could
In
be a
terms,
function in terms of what?
in terms of L.
Nah, U is a function in terms of x.
Oh. Oh,
So
okay.
you understand, we could replace U for anything.
Yes, sir.
But the whole point is that the whole thing there is the outer function. And in this particular instance, what is the inner function? What are we putting into that u to the power 9? What is the inner function?
5x plus 8.
Exactly, 5x plus 8 is the inner function. Okay, a little bit more like now.
Yes, sir.
I'm gonna go over it again. So Jenna, if you have something like u to the power 9, then whatever you input, you're gonna raise it to what power? You're gonna raise it to what power?
To the power 9.
Exactly. And in this particular question, what are we inputting for u?
L. Wait, no. 9.
What are we inputting for u? What is u?
Oh, U is 5x plus 8.
Right. So the outer function will just raise everything to the power 9, and what are you putting in that function?
5x plus 8.
Exactly, because it's 5x plus 8 to the power 9. So you could see that the outer function is just raising everything to the power 9, right?
Oh,
And what is the inner function that's being raised to the power 9?
5x plus 8.
Exactly. So you understand that the outer thing there, that's the whole u to the power 9 is the outer function. Now the inner function is what you're putting into that. You with me?
Yes, sir.
Okay, so let's try to make an analogy here. So a lot of people are watching this on live will not understand this. This is like I feel like you have to have some prerequisites to fully understand this when it comes to differentiation. So this is more like kind of tailored, right? But yeah, so Jenna, I want you to observe carefully what you did here. So you see a 9u to the power 8 there. That's the derivative of the which function? The inner function or the outer function?
The outer function.
Exactly. So 9u to the power 8 is the derivative of the
Outer function.
derivative of outer. And this 5 is what? What's the 5?
The derivative of the inner function.
And that is chain rule, you know. That is the whole chain rule. That's why I hear some people saying outer by inner.
Oh.
So I'll generalize this just now. Right? But we knew that u was what? What was u? What was u?
U is 5x plus 8.
So we'll say 9 by 5x plus 8 to the power 8 multiplied by,
Multiplied by 5.
right? And you will get the answer 45 5x plus 8 to the power 8. You girls with me or not?
Yes, sir.
Virginia, let me know if you're with me.
Oh, yes, sir, I am.
So let me give you another question, and I want to generalize this thing just now. Let's look at another one. And Jenna, yeah, I get this. So Jenna, like, if I tell you v was equal to, I don't know, 2y squared plus 7 to the power 5. Jenna, a way to identify What do you think is the outer function?
U to the power 4.
Yes.
Yeah.
Yes. Yes. Big up, Jenna boy. Yeah, because you could say that, you could always say, let u be equal to 2y squared plus 7. And if that's the case, then v is just u to the power 5.
Yes,
So, u to the power 5, this is the outer function. And we're putting into that function. What are you putting into that?
the inner function.
What is the inner function? Like what you're putting into
Oh,
u to the power 5. What are you
2y,
raising to the power 5?
2y squared plus 7.
Yes, yes, precisely. So do you understand that whatever you were to put in here would be raised to the power 5?
Yes, sir.
So that describes the outer function.
Okay.
And whatever you're putting in into that outer function is the inner function, right? Would
Okay.
you agree that this 2y squared plus 7 is a function?
Yes, sir.
Okay, cool. So just to make sure, we understand that u to the power 5 is the which function?
The outer function.
And we understand that 2y squared plus 7 is the
Inner function.
good. I'm telling you guys, after today, you're not gonna have any problems with chain rule. Like, I swear, I swear. I'm gonna,
Okay.
I'm gonna, I'm gonna like reframe how y'all think about it. Um, so, Jenna, how would I continue?
So
Jenna, before we continue, right? Look at the original question. If we were to differentiate that, what would be what would be differentiating? Hmm. What would we be differentiating?
you say what would we be differentiating?
Right. So,
So
anytime I say what would we be differentiating, I'm asking you, what would be changing with respect to what?
so you would be changing with respect to y.
Yeah.
So
So
du.
yeah, yeah. Because and depending on what y is, you would change.
Yes, sir.
Yeah, yeah. That makes sense. So what would the answer be? What would the answer
For
be?
y.
The answer would be for y. Yeah. And what is changing into okay? Like what is changing with respect to what there?
V is changing with respect to u. So dv du.
So you understand? Depending on what u is, like if u was 0, okay, like v would be 0. If u was 1, v would be 1. If u was 2, v would be what?
2.
Now,
Wait. Wait, what did you say? Sorry, repeat.
if u was 2, what would v be?
2 to the power 5.
Exactly. So, can you clearly see that v is dependent on what u is?
Yes, sir.
Alright. So, dv du would just be what?
5u to the power 4.
Great. Now, using chain rule, we could connect those two different rates of change to answer the whole question, like the big question. What's the big question there? What's the big question? What's the big question? Tell me, General, like if you look at the bigger picture, like a step back, ultimately, what is changing with respect to what?
V is changing with respect to u.
Yeah, sure, v is
Like,
changing with respect to you. I'm talking about step back
I
to the
mean,
original problem.
V is changing with respect to y.
Yeah, because depending on what y is, wouldn't v change?
Yes, sir.
Exactly. So v would be equal to, well, what's it? We want to
D,
find dv what?
dv dy.
We want to find dv dy. How would you find dv dy?
So it'll be dv on top and dy at the bottom and du because they cancel off.
Bad, bad, bad. Right. So what is dv du?
Does 5u to the power 4 multiplied by 4y?
No, again, Gills, again, right? 5u to the power 4 is what? What is that? What is that?
The
What is that?
derivative of um u to the power 5 of the outer
And
function.
right. So, Virginia, you starting to see something like
I'm seeing a pattern.
Yeah, yeah. Like this is gonna, like I'm telling you, like gonna hit a little like a brick just now. So this is the derivative of the outer function, right?
Yes, sir.
And that 4y, that's the derivative of the what? What's that
Inner
4y?
function.
The derivative of the inner function.
Yeah, this is the derivative of the inner function. Isn't that what we just did in the previous question too?
Yes, sir.
So like maybe we could generalize this, you know? But just to make sure all of us are on the same page, I'll give you all an example with sine. Give you all an example with sine. But
Okay.
the answer for this will be 5 by 4y, which is 20y, and what's u to the power 4? Or what's u? What's u to begin with? What was the inner function?
2, 2y squared plus 7 to the power 4.
So I'm gonna take off the training wheels and introduce you guys to a different notation. So in all of these instances, it had an output. Over here the output was L. Over here the output was V. But let's strictly look at the rate of change. So what if I give you all a question like d dx 5x 5x plus 9 to the power 8. How would you do that? Tell me, Jana, how would you do that?
Um,
So Jana, did anything change? Like talk to me like in this question, we want to differentiate 5x plus 9 to the power 8 with respect to what?
with respect to x.
Right. No, I can't blow their mind even more. I can't blow their mind even more. What if I told you guys that y was equal to 5x plus 8 to the power 9? Then I could write that as, I could replace it with y and I could have said dy dx. Wouldn't that
Wait,
have been a
no,
more
to the
familiar
power
one?
9. Do you mean to the power of 8?
Yeah, I mean to the power of 8. Sorry
Oh,
about
okay.
that.
That's okay.
Yeah. So Virginia, here we're saying, right? This looks a bit unfamiliar, right? That looks a bit unfamiliar.
Yes, sir, it does.
But what if I told you that, what if I said that y was equal to 5x plus 9 to the power 8? Then suddenly it becomes dy dx. I'm not sure if you see what I did.
I
What's that?
guess
What's that, Virginia?
that's d dx or y, the function. I don't know.
That's y, right? That's y.
Oh,
Yeah, I just defined it as y.
okay. So it doesn't matter.
I mean, it doesn't matter. Talk to me.
Like, you know how you just change d dx to y? Does it not matter the variable or?
Well, let me explain.
Okay.
So Virginia, if I told you that 5x plus 9 to the power 8 was y, like, okay, what if I told you that was a function and it was y is equal to 5x plus 9 to the power 8? Then
Mm-hmm.
what could you replace 5x plus 9 to the power 8 with?
Y?
Exactly. So that's why I say in dy dx.
Oh, okay. I understand now.
Like what? I just replacing this with y. Dy dx.
Oh, okay. Yeah.
So it's nothing y'all are unfamiliar with, even though it might look a bit scary.
So
Yeah.
you're
Now,
essentially just making it equal to y. Or like,
yeah, like if okay, um, if okay, so let's just say that's a function, right? This is a function. Can you all see that this is a function?
yes, sir.
Yes, sir.
That's a function. If we define it as y is equal to 5x plus 9 to the power 8, then wouldn't this just be y?
Yes, sir.
Oh, yes, sir.
So wouldn't that be dy dx?
Oh,
Yeah. Okay, I
oh,
understand now.
yeah, that makes more sense.
But I'm
The
stripping
notation
away.
just threw me off.
Yeah, but that's what I want to do. I want to throw you all off. I want to remove. Okay, I want you all to disassociate from things like the ydx, right?
Okay. Yeah.
the important thing is you all realize that this is something you're accustomed dealing with, right? It's just looking a bit different.
Yes, sir.
So we have to differentiate 5x plus 9 to the power 8. What would you use for that? Jenna, typically speaking, what would you use for that, Jenna?
Y is equal to 5x plus 9 over 3 power 8.
Well, what rule would you use? Like the product rule, quotient, chain rule? What
Oh,
would you use?
chain rule.
You would typically use the chain rule, but it's a bit different and yeah, like it's a bit different how you're accustomed to, right?
Yeah.
Like like typically you would have an output. So it's a kind of bit different.
Yes, sir.
But it's the exact same concept.
Okay.
And so from the last couple of examples, you would have seen that if you want to differentiate um outer function with a function on the inside, you just differentiate the outer function and you multiplied by the
Inner function.
right. So we could actually figure this answer out really fast. So question guys, what would you all class as the outer function? What would you all say is the outer function? You have to say.
Um, what's in brackets to the power of 8? So like u to the power of 8.
Right? This is the outer function. What would you all say is the inner function?
5x plus 9.
So here's what I want you to do for me. I want you to differentiate the outer function. What would that be?
8u to the power of 7.
That would be 8u to the power 7, but what's u though? What's u? What is u?
5x plus 9.
Exactly, so we could just say 8 by 5x plus 9 to what power?
To the power of 7.
Right? Multiplied by the derivative of the inner function. What's the inner function, Jenna?
5x plus 9.
Alright, differentiate that from her. If you differentiate 5x plus 9, what would you get?
5.
You get 5. So your answer is just, 8 by 5 is 40. 5x plus 9 to the power 7.
It was like a shortcut, basically.
Yeah, because okay, Jenna, in those two examples you looked at above, you
It
would
was
have
just what
seen
I
that
would.
you'd have seen that the chain rule, what it does is it's just a product of the derivative of the outer function by the derivative of the inner function. See that?
Yes, sir.
So when you see a question like this, it's a weird power, that is actually chain rule. But you could just do the shortcut. Right? And you know that the shortcut is just the derivative of the outer function by the
Inner function.
derivative of the inner function.
Derivative of it. Yeah, sorry. Derivative of it.
So if you saw something like d dz minus 7 plus 8 z squared to the power 4, how would you work that out, Jenna? How would you work that out?
So, 4 open bracket minus 7 plus 8c squared by
So what power? Remember, that would have been the outer function, and so the
by
outer function would have be u to the power 4. And so when you differentiate that, what would that be?
so to the power 3.
Yeah.
And
So
then
4 by minus 7 plus 8z squared to the power 3.
power 3
And you would have multiplied by
multiplied
that
by
by what?
16z.
Yeah. So you understand, we kind of like skipping this whole thing and just jump into here.
Yeah. I see it now, Loki.
So this is a shortcut. And when you work that out, 4 by 16 is 64. So that's going to be 64z by minus 7 plus 8z squared to the power 3. Virginia, let me know if you understand that.
Yeah, that's like the shortcut you've been using all along.
Yeah.
Oh,
I'm just trying to show you guys that it literally comes from this.
yeah, I understand now. I was having problems with that. Thank you, sir.
No problem. So Jenna, we could actually generalize the chain rule. So let me show you what I mean. So Jenna,
Yes, sir.
if I want to differentiate Stay with me, right? This might get a bit confusing. Just to make sure you all are with me, even though you might not recognize it, there's an inner function there and there's an outer function. Jenna, what is the inner function there?
5x plus 9.
What's the outer function?
Y- Um, u to the power 8, or like whatever's in the brackets to the power of 8.
U to the power 8.
Okay, u to the power 8.
Because let me explain something, Jenna. The outer function is saying, whatever you put inside our brackets is being raised to the power 8. You understand?
Yes, sir.
Okay.
So we say u to the power 8, but it's not actually written there. We were just saying that.
Well, when we do implicit differentiation, you go see.
Okay.
Because, Jenna, I have a question for you, right?
Yes, sir.
In this instance, don't you know what U is?
Yes, sir.
Like, you know U is what? Where's U?
U to the power 8. I mean,
No,
what?
like,
Sorry, u is 5x plus 9. Sorry.
exactly. So you know what it is,
Yes, sir.
right? Virginia, implicit differentiation asks us, what if you did not know? What if the function was unknown? So you'll see what I mean when we get there.
Okay.
So, long story short, Jenna, the chain rule is saying you have the outer function f of x, and inside that you have some function g of x. So, I feel like I'm losing you, so let me go back. So, Jenna, maybe the outer function here, we could call it f of x. What would the outer function be defined as?
In this question,
Yeah.
the outer function will be u to the power 8.
Well, if I do, I should really call it f of u, right? So I would say u to the power, yeah, f of u is equal to u to the power 8. Cool.
Yes, sir.
And what would I say the inner function is?
5x plus 9.
Exactly. So we could actually refer, like, okay, to generalize it and make it a bit nicer, you could just refer to the outer function as f of x, and you could refer to the inner function as g of x.
Okay, I understand.
Okay, good.
Yeah,
And so this over here, that f, that's really the what?
that's the
This,
outer.
that's really the outer function.
Yeah,
This is really the outer function. And what do you all think that g of x is?
the
What do you all
inner.
think that g of x is?
The inner function.
Yeah, this is the inner function. Now, you guys may not know this, but anytime you want to represent the first derivative, like, okay, if you wanted to represent the first derivative of a function f of x, that would just be f prime x. Do you all know that or no?
Yes, sir.
Um, Jana, what about you? Did you know that?
F prime x is the derivative of f.
Yeah, the first derivative
Yeah,
of f of x.
first derivative. Yes, sir.
Okay.
And double prime will be the second derivative, right?
Yes.
Okay.
So, Jenna, so we're saying that, so we are saying, what we're saying is, f of x is the outer function, and g of x is where you put an into that.
Yes, sir.
Do you all now understand why I was saying we use chain rule for composite functions? Because they put in one function into another function.
Yes.
Oh,
Mm-hmm.
A
okay.
composite function is when you put in one function into another function.
Oh, right.
Okay.
So like you have a function f of x, right? And into that, what you plugging in? What are you plugging in?
G of x.
Yeah, g of x. You understand, Jenna?
Yes, sir. It's like normal functions in maths, but like,
Yeah, it is. This is a composite function.
yes, sir.
So like, as you can see, if I plug in g of x into this, wouldn't that be f g of x?
Yes, sir.
Great.
Oh, yeah. Yes, sir.
You see it? It clicked.
Yeah, I've seen it. I've seen it. Yeah.
All right, bet. Now, we were able to generalize that the chain rule is just the derivative of the outer function by the what, Jenna?
Sorry, sir. By the inner function.
Exactly. So you understand that, right?
Yes, sir.
All right, cool. So how are we gonna write that though? in notation form, how are we going to write that? So remember, f of x is the outer function and g of x is the inner function. So like, how are we going to write that though? My
So
question. So
with
you know for a fact that it's derivative of the outer function by the derivative of the inner function. And you know f of x is the outer function and you know g of x is the inner function. So how would you write that?
would it be df dg or no?
Nah, remember we're using prime notation. We're using prime notation here to make it a bit simpler. So here what? I'll help you out a bit.
Okay.
So it's the derivative of the outer function, right?
Yes, sir.
Right? Now what was in the outer function?
F of x.
Nah.
No,
What was in the outer function?
g of x.
Exactly. Right? So you see this over here? This is just the derivative of the
Outer function.
yes. So Jenna, you might be confused, probably saying, but sir, why have g of x there? You're probably wondering that.
Yeah.
Okay. Um I want to ask a question. If you have something like L is equal to u to the power 9, and you ended up with 9 u to the power 8,
Yes, sir.
what did you end up plugging back into that? Not the inner function?
Oh, yeah, because the inner function is f 5x
G of
plus.
x. The
Yeah.
inner function, well, in that case, is g of x. So,
Yeah.
like understand it. So,
Mm.
like, L is equal to u to the power 9 in that case, right? So, that is the. Do you understand that is the outer function?
Yes, sir.
And then we're going to differentiate the outer function. You with me so far?
Yes, sir.
But when you differentiate the outer function, what do you plug back in?
The inner function.
Yeah. So, you differentiate the outer function and you put back in the
Inner function.
yes. You understand?
Yes, sir.
Right. Let me know if you're okay with that.
Yeah, I think so. Yeah.
Okay. And we're going to multiply that by what?
Um,
So remember, it was the derivative of the outer function by the
Inner function.
right. If you differentiate the outer function, what's saying? If you differentiate the inner function, what would the notation for that look like? Using prime notation, what would that look like?
G prime of x. G prime x
Yeah. Yeah, g prime x. And this would represent that you're defining the derivative of the
of the inner function.
yeah. So that's me generalizing the chain rule. So that's what you're doing for every single example of the chain rule. You're finding the derivative of the outer function, right? But Jenna, when you find the derivative of the outer function, what is inside the outer function?
The inner function.
Cool. And you're going to multiply that by the derivative of the inner function.
Yes, sir.
You understand?
Yes, sir.
So let me lock in with a couple examples before I show you how implicit differentiation comes into play. So let me try 9x plus 8 to the power a half. So you tell me what there is the outer function.
A half.
A half.
Wait. Yeah.
Take your time.
U to the power of a half.
U to the power half. Cool. What is the outer function? Sorry, we just talked about the outer function. What's the inner function?
9x plus 8.
Exactly. So we're gonna find the derivative. This, I see Stephen say chain rule is easier. This is chain rule. This is the chain rule. This is the classical definition of the chain rule. Like, this is the chain rule. I don't know. A lot of people don't learn it like this in school, but this is the definition of the chain rule. The definition of the chain rule is that it's the derivative of the outer function by the derivative of the inner function. So, Jenna, when we're doing this now, we're going to differentiate the outer function. So, if you differentiate u to the power half, what that will be?
a half u to the power negative a half.
Right, but remember, we had to replace u with the what?
Oh, right, yeah. So 9x plus 8
And what the power will be now,
to the power negative a half.
right? And remember, you had to multiply that by the,
Derivative of the inner function, so multiply by 9.
yeah. And so you're gonna get 9 over 2 by 9x plus 8 to the power negative a half. How you feel about that?
Oh, yeah, I've seen it. I've seen it.
Virginia, you seeing it clear now?
Yes, sir, I definitely am.
So here's what. Let's try to apply this to a sine function now. So Jenna, let's see if you understand it for the sine function. So again, I'm gonna start you off really simple. So let's consider we had, y is equal to sine 5x. Right. So Jenna, what
Yes.
would you think is the outer function there?
5x. No,
Nah.
sine.
Sine u.
Yeah. Sine u, sorry. Oh, yeah,
Right?
yeah, right,
Yeah. And what you're
yeah.
putting into sine? What are you putting into sine?
5x.
Right. Yes. Yes. You see how you're seeing it now?
Yes, sir.
So you know what? Let me jump straight to it, like straight to the bullet. I think you could do it.
Oh,
So remember, it's the derivative of the outer function. So the outer function in this case is
sine.
sine, sine u, right?
Sine u. Sorry, I keep forgetting u. Sorry.
Right? And you have to find the derivative of the outer function. If you differentiate sine, what would you get?
Neg. Cos x.
But remember, what would you have inside there? So you differentiate
It's
the outer function. Mm-hmm.
Wait,
What's
so
in?
cos open bracket 5x
Yeah.
multiplied by 5.
Yes. That is it.
Okay.
Bigger, 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 bigger.
But sir, I have a question.
Talk to me.
You know how you say like sine x represents like the derivative? No, cos x is the derivative of sine x. So x just represents any inner function.
Exactly. Yeah. Yeah.
Oh, okay. Understand now. Because I was really confused, like where the X would go before.
So, Virginia, trust me, when I move on to implicit, it gonna make so much sense. But do you all
Okay.
feel like you understand the whole concept of chain rule?
Yes, sir, I do. 100%.
Okay. Okay, good. I might lose you all here, but
Oh,
but like I prepared notes and thing for this. Like,
okay.
because I didn't want to go into this blindly. I wanted to make sure you guys kind of have ideas to what happening.
All
Okay, so
right.
stay with me, right? Stay with me. Stay with me, guys. Stay with me, please. So let me just say, we had to differentiate y squared with respect to x. No, no, guys. Instead of thinking about it like y squared, let's think about it like, yeah, let's think about it like that. Now, from the prior instances, you would have seen that y could be a function in terms of what?
In terms of X.
Yeah, Jenna. And y could be a function in terms of x, like maybe y could be 5x, maybe y could be 7x plus 3.
Yes, sir.
But in implicit differentiation, you don't know what it is. So Jenna, stay with me.
Wait, when you say you don't know what x is,
Say that
or
again?
you don't know what y is. That's what I'm
Yeah,
interested.
it's actually called the unknown function.
Oh, okay, that makes more
So
sense.
like let me explain, right? Let me explain. So y is literally some unknown function in terms of what?
In terms of x.
Exactly, exactly. You are going to be mind blown, like shattered, like trust. right? So y could be some unknown function in terms of x. Do we all agree? Like y, maybe y could be 5x, maybe y could be 7x squared plus 3, I don't know. But
Yes,
what I'm
sir.
saying is y could be some function in terms of x. You just don't know where it is, right?
Okay.
Right, Jenna, do we know what that unknown function is?
No, no, because it's
No.
unknown.
It's unknown,
Yeah.
right? It's unknown. Stay with me. Let's apply the same chain rule hack here. I'm telling you that y could be some unknown function in terms of x, right? So, talk to me. What would you guys say is the outer function in this case?
U squared.
Good.
You would say u squared. Okay. And what is the inner function?
Why?
Y.
Great. Great. Let's apply the chain rule here. Stay with me, ladies. So that would be equal to the derivative, right, of the outer function. Differentiate the outer function for me.
Uh, 2U.
U.
Right? But in this case, what is the inner function?
Y.
Right? So I'll write 2y. Wait, let me run back that again. Right? So Jenna, do you understand that u squared is the outer function and y is the inner function?
Inner
Like,
function. Yes, sir.
depending on what y is, you actually plug in that into u.
Yes, sir.
Okay, good. You're sticking with me then.
Mm-hmm.
All right. So Jenna, we'll differentiate the outer function. If you differentiate the outer function, what would you get?
2U.
Right. But what is the inner function you're putting into that?
Y.
Right. So we'll say that. So we'll say what?
2 open bracket Y. So 2Y.
2y. Good.
Yeah.
And we're gonna multiply that next by the
By the inner function. So multiply by Y
the
squared
derivative of the.
of the inner function.
No. This is the part I'll blow their mind. This is the part. This is the part where I'll literally blow their mind, right? Over here, don't I know what the inner function is?
Yes, sir.
Yes,
Jenna,
sir.
don't I know what the inner function is there?
Yes, sir.
So if I know what the inner function is, then I could differentiate it and get a known derivative.
Yes, sir.
Okay. Do we know what the inner function is over here?
No.
No. Virginia, do you understand that we don't know what the inner function is, right? We don't know what the inner function is.
Yes, I understand.
But Jenna and Virginia, that inner function we know that it will be in terms of
X.
exactly. So that would just be dy dx.
Yeah.
Let me run it back again. Jenna, you there?
Yes, sir.
So it's gonna be multiplied by the derivative of the inner function, right?
Yes, sir.
We don't know what the inner function is, but we know that it will be in terms of what?
In terms of X.
Right. So you can't differentiate, like, okay. Like, you see in this example, where you knew what the inner function was?
Yes, sir.
Like,
5X.
you knew it was 5x plus 8, right?
Yeah. But
If
this
you
in case we don't.
We didn't know, but I'm gonna ask that question, right? If you didn't know it was 5x plus 8, wouldn't the derivative still be du dx?
Yeah. Yes, sir.
Exactly. So, like, here what I'm saying, right? If you didn't know, let's stay with me, right? If I didn't know that u was 5x plus 8, right? Would I be able to calculate du dx? Like, would I be able to calculate that exact, like a known derivative for du dx?
No, sir.
No, sir.
No, I would not. So, but I do know that u is some function in terms of x. So the derivative will be du dx. We just don't know what the function is. So in that instance, I'll leave du dx here. And if you tell me what u is, I will be able to find du dx. But I'll just leaving it here for now.
Okay.
Right? I see how it's a bit confusing. So, like, let me explain. Jenna, if I told you that y was 5x, right? If I told you y was 5x, wouldn't you go ahead and replace y with 5x here? And wouldn't you differentiate? Wouldn't you find dy dx here? Put 5 and put 5 over here?
Huh?
Okay,
What?
let me run that back again. Let me run that back again to make sure you understand. Right, so Virginia, if I told you that y was, let me just say y was 7 plus x, right?
Yeah.
Wouldn't that be 7 plus x squared?
Wait, why? Oh yes, yes. Sorry. Yes, it would.
Oh,
Yeah.
right.
Mhm.
Yeah.
Okay. And how would you guys work that out? How do you guys work that out? Using the chain.
So
Um.
u squared. So
Mm-hmm. And you
so
differentiate that. So what would that be?
2u.
Right? And what's the inner function in that case?
Oh, right. So 2 open bracket 7 plus x
Yeah.
multiplied by 2u. No, wait, sorry. Multiplied by 7 plus x.
No, remember derivative of the inner function.
7. 1.
No, this is the part where I blow all in mind literally. Literally. Watch. Jenna, what is 7 plus x? What is 7 plus x?
A function is y.
Is y.
Yeah.
And 1 is just the derivative of
U squared. The outer function. Sorry.
no, the inner function.
Yeah.
And the inner function was y is equal to 7 plus x.
Yes, sir.
And so if you differentiate that inner function, 7 plus x, you get 1, right?
Yes, sir.
And so that 1, doesn't that 1 just represent dy dx? Think about it though, think about it.
Oh, yeah. Yeah.
Now, the only reason we could have find 1 is because you knew what y was. What was y?
Y was 7 plus x.
But if you don't know what y is, what will you just have to leave?
Leave it as y.
Take your time. So, the only reason you was able to find that it was 1 is because you knew what y was, right?
Yes, sir.
And because you knew what y was, you could have find 1. You could have find.
dy dx.
Exactly. Now, if you don't know what y is, but you know it's some function in terms of x, you could just leave it as what?
d over dx.
dy dx.
dy dx.
Yeah.
Okay.
That is implicit differentiation. That's where it comes from. It's just chain rule. I'm gonna go over that again because I feel like we're still very confused. This is a really good example. So I'm gonna use this example again. So stay with me, guys. If we have something like d dx of y squared, right? Right? d dx y squared. And Jenna, give me a function for y. So like what give me a function for y in terms of x. Give me a function.
7 plus x.
Nah, let me do something different.
Okay, sorry. 5 plus x.
Nah. You're going too easy. Come on.
5 plus 2x. Okay.
You read my mind. I put 2x plus 5, it's 5 plus 2x. Right. Now, if you were to differentiate that, you would replace y with what? What would you replace y with?
2x plus 5 squared.
Right? So you would now write d dx 2x plus 5 squared. And you understand that, right? That makes perfect sense. That makes
Yeah.
perfect sense for you.
Yes, sir.
Okay. Using the tricks we just learned, how would you differentiate that? How would you differentiate that?
So 2x plus 5. Wait, no. Hold on, sorry.
Take your time.
Right, so 2 open bracket 2x plus 5.
So you differentiated the outer function
Yeah.
and you put back the inner function into it, right?
Yes, sir. Yeah.
Cool. And you're gonna multiply that by what now?
Multiply by 2, which is the derivative
Guys.
of the inner function.
Exactly. Now, stay with me. Stay with me. Stay with me, right? Stay with me, right? Stay with me. Look, if I did not tell you that y was equal to 2x plus 5, I never told you that. Like, we didn't define it. Then, look how it would be. So, like, tell me, Jenna, if I didn't tell you that, this was, like, if I didn't define y, then 2x plus 5 would have just be y, right? Like, can you see that 2x plus 5 is literally defined as y? Like, y is equal to 2x plus 5. Y is equal to 2x plus 5. Can you see that?
Yes, sir.
So, that would be 2 by y. And how did you get the 2? How did you get the 2? Where did you get the 2?
Um, the derivative of the outer inner function.
Which is y is equal to 2x plus 5. So, that'll be what?
2.
Right, tell me the full working. Tell me the full working.
But, dy dx is equal to 2.
Right, but if I did not tell you that y was equal to 2x plus 5, but you know y was some functions in terms of some function in terms of x,
Mm-hmm.
then instead of 2, you'd have put what? Symbolically, where'd I put?
I would say y.
Nah, let me go back. Let me backtrack one.
Or is it d over dx?
Nah, it's not d over dx.
dy
Let me
over,
backtrack. Yes.
because
Because,
it's
okay,
the derivative
yeah, how you
of
get 2? How did
y.
you get 2? How did you get 2? By doing
The
what? By finding what?
derivative of the inner function,
Which is y is equal to 2x
which
plus
is y
5.
equal. But if we don't know what y is, then you just use what
You just
that
use
is
dy
then.
dx.
Yeah. Okay. Okay, I get it. Kind of, yeah.
Virginia, you understand it?
Yes, sir. I'm on board. Don't worry.
Okay, so like let me run it back again.
Okay.
So, Jenna, I'm telling you, like, okay, I'm telling you that I'm defining y. I'm defining y for you. I'm defining y, and I'm saying that y is equal to 2x plus 5. If y is equal to 2x plus 5, then I could replace y with 2x plus 5 squared, right? And the only
Yes.
reason you could do that is because I defined what y was. I defined what y was.
Yeah.
I tell you y was equal to 2x plus 5.
Yes, sir.
So that's going to be 2x plus 5 squared because I defined what y was. Now, how would you differentiate that using the chain rule? Remind me, what's the process?
So u squared multiplied by 2.
Run it back again. So you're going to differentiate the what function?
Differentiate the outer function. So that's 2u. 2 open bracket 2x plus 5.
Right? Because you plug back the inner
Like,
function into it.
yeah. Multiplied
And-
by the derivative of the inner function, which is 2.
Right. Now, let us... okay, let's try to generalize our findings. So at the start, what did I tell you 2x plus 5 was? What did I tell you that was?
That's y. Y is 2x plus 5.
So I could just say 2y. Okay.
You
And
right.
how did
Oh,
you get
yeah.
2? By
That
doing
was
what?
the derivative of the differentiating the inner function,
Which
which
is...
is dy dx.
Yeah.
Oh,
Which is dy dx.
okay, I understand.
So this is the part where blow your mind even further. Stay with me. So, Jenna, what if I told you that I can't change the value for y, right? What if I told you y was, 9x squared plus 8? Right?
Yes, sir.
Then to find our answer, I could just say 2 by 9x squared plus 8 multiply by 18x. Because that's what it's telling me. If I want to differentiate y squared, I just do 2y by dy dx. Over here, what did I do to the value? What did I do for the function of y?
Differentiate the outer function by the inner
Now,
function.
wait a let me take my time. Over here the function, okay, over here the function was y, for y was defined as what? What was the function for y defined as?
2x plus 5.
What did I change here?
What y is equal to?
Exactly, I changed what y was equal to. You understand?
Yes, sir.
I changed what y is equal to. But what I'm saying is, if I asked you to differentiate, if I asked you to differentiate 9x squared plus 8, isn't that in the same form as d dx y squared? Isn't this the derivative of y squared? Well, sorry. Isn't that the derivative of y squared?
Yes, sir.
And we found our general solution to be 2y by dy dx.
Oh,
So
okay, yeah, I've seen it now.
2 was y.
Y is 9x squared plus 8
And we're multiplying that by?
by the derivative of the inner function, which is 18x.
Yeah.
Okay.
So what we came up with here is a general solution to if you had something like d dx y squared. So if you have something like d dx y squared, the general solution is just 2y multiplied by whatever dy dx is.
Okay, yes, sir. I see it now.
Virginia, you see it or not?
Yes, sir. Don't worry, I'm understanding.
So Virginia, if I had y is equal to 3x plus 16, and I tell you to find d dx of 3x plus 16 squared, isn't that in the form d dx y squared?
Yes, sir.
So then the answer would just be what?
2 3x plus 16 by 3.
That's it.
Yep.
So implicit differentiation is kind of like a generalization in a sense. Because
Okay.
when you do an implicit differentiation, do you know what that inner function is?
No, it's unknown.
But you know is a function in terms of what?
In terms of x.
Exactly. Exactly.
So, sis, when you differentiate implicitly, it's always a function y in terms of x. Or does it ever change?
It could be any variables.
Okay. Okay, I understand.
But I'm just using y and x because you're a lot custom with y and x.
Okay, no problem.
So let's use a different example to just see if you all really understand implicit differentiation.
Okay.
So, Jenna, let's just say I tell you to differentiate y to the power 5, right? And just to make sure you're with me, I'm going to write it like that. So, Jenna, what would you use to differentiate that? Which rule? Product, quotient, or chain?
Yeah, chain rule.
You would use the chain rule. Now, Jenna, as it stands right now, y, we know that y would be a function in terms of?
X.
Right, y would be a function in terms of x, but do we know what the function is?
No, sir, we don't know what y is.
No, but that's useful because you saw this previous example, right? Like if you define what y is, that's just
If-
one instance. But like if you did like okay, in the last example, didn't I come up with like a general solution for the derivative of y squared?
Yes, sir.
Yeah, and I would get my answer simply knowing what y was. So in implicit differentiation, we are considering an unknown inner function, but we know that the inner function in this case, we know that it's in terms of x. So y is an unknown function in terms of what?
In terms of x.
Exactly. Good. Cool. So long story short, how would you differentiate a function that you know in terms of x? That would just be what? Tell me, Jana, like
The derivative of the outer function multiplied by the derivative of the inner function.
you're not wrong, but like I just asking you for this specific question.
Oh,
If you had a function y is equal to something in terms of x, when you differentiate that, what would the notation look like?
dy dx.
Exactly. Cool. So let me do this question. So tell me, what is the outer function? What's the outer function?
5y. But sorry, 5. U to the power 5.
Right? And in this case, what are we putting into the function?
U. Y.
Take your time. Y.
Yeah.
So do you understand that u to the power 5, this is the outer function, and y is the inner function.
Yeah. Yes, sir.
You sure you with me?
Yes, sir. Yes, sir.
Good. So differentiate that for me.
So 5y multiplied by dy dx.
Now take your time. So remember, you're going to differentiate the outer function. If your outer function is u to the power 5, how would you differentiate that?
Or 5u to the power of 4. Sorry.
Right. But remember, you have to plug in the inner function back. So what's
Right.
the inner
So
function?
5 open bracket y to the power of 4
Exactly. And you're going to multiply that by what?
by the derivative of the inner function, which is y. dy dx.
Yes. Yep. That is it. That's implicit differentiation. Implicit differentiation is just the chain rule.
Absolute cinema.
So let me show you guys why this is so cool. Like, let me show you all why this is so cool, right? We've just found a general solution for the derivative of some function in terms of x to the power 5. Like, let me give you an example, right? Like, let's look at these questions. Examples. So Jenna, what if I ask you to differentiate 7x plus 3 to the power 5? Well, in that instance, Jenna, what would you say y is? In that instance, what would you say y is?
7x plus 3.
Exactly. So it'd just be 5 by 7x plus 3 to the power 4 multiplied by what?
Multiplied by 7.
Yeah. If you had something like ddx minus 8x squared plus 7x plus 3 to the power 5, wouldn't that exact same rule we come up with work?
Yes, sir. So 5. Or
No,
see
but
it?
I mean, sure, you could say it. So that'll be 5 by.
Sorry. 5 by negative 8x squared plus 7x plus 3 to the power of 4 multiplied by negative 16x plus 7.
Yeah. Yeah.
Okay.
So,
And
like, by us differentiating implicitly, we actually came up with a general solution. So if you have something to the power of 5, you just found the general solution. Because remember, why does that work? That works because when you differentiate implicitly, you're saying that y is just some unknown function in terms of x. If you define it, then you could solve it for that specific function. That specific inner function. Yeah. So, Virginia,
Yes, sir.
let me give you one to try.
Okay.
So what if I asked you to differentiate 5y to the power of 7?
Okay. So that would be 35y to the power of 6 by dy dx.
Yep, that's it.
Absolute cinema. This is pretty cool though.
Yeah. Yeah. And you all did that. You all learned that. So like now they understand the concept of implicit differentiation. Implicit
Yes, sir.
differentiation just comes from a chain rule.
That's pretty awesome though.
Yeah.
It really helped me with the shortcut, how you explained it, because I was really confused and I wouldn't guess it before. But now I'll do it in like 2 seconds. Trust.
I tell you, like now you understand it, right? It's just
Yeah.
you're just differentiating the outer function and then multiplying it by the derivative of the inner function.
I can't believe it's so easy because it seemed so challenging just the other day, like some hours ago.
I feeling bad for the people I missed this session. It should have
Yeah,
been
for
here.
real. At least
Like,
they could watch the recording on YouTube.
I don't they will do that. They're gonna be at a
Oh.
serious disadvantage.
Oh.
But I will post it. What's
Okay.
Jenna? Jenna, let me lock in, right?
yes, sir.
So Jenna, what do you think? What do you think is the outer function here?
U to the power 7. I mean, yeah.
Now you're not wrong, but you're gonna run into some problems. Like we're gonna do that 5.
Oh,
Like, let me keep going. I want to see what you're gonna do. So you can say use the power 7. And what's the inner function?
5y. to the
Nah,
power 7.
nah. Is 5y being raised to the power 7, or is it just y being raised to the power 7?
Just y.
Just y. So what's the inner function? Is it 5y or is it just y?
Y.
It's just y. Y is the inner function. Yeah, like, okay, if I told you y was equal to 2x plus 1, then you would say 5 by 2x plus 1 to the power 7. You understand?
Yes, sir.
Yeah. Now, here's what. You see how you're multiplying? Okay, 5 is a what? Max, I have a question. 5 is a variable, 5 is a constant. What is 5?
It's a constant.
5 is a constant. You multiply by a constant. So like you could just like, okay, if you want, when I ask you what the outer function is, you could just sum of 5 to the power 7.
Okay.
Because let me explain. Jenna, look at this, right? This accepts an input for what? What does that accept an input for? Or is it one variable there?
Y.
Right. So that accepts an input y, and depending on what y is, this would change. Like, okay, if I tell you y was equal to 7x plus 1, wouldn't that become 5 by 7x plus 1 to the power 7?
Mm,
Okay, so I just tell you that y was equal to 7x plus 1.
oh,
So
right,
you
yeah.
replace,
Yeah.
so you
Yeah.
replace y with what? What do you replace y with?
7x plus 1 to the power.
Yeah. Yeah? And yeah, that's correct, tough. That's correct. I want them to develop an intuition for it though. Like, a lot of people watching these lives will be like, I mean, you could have just teach each other on how to just, just do it. But I want a little think deeper than that. I want a little like develop a deeper intuition. Like I want a little use of the brain. Um, I don't want to just tell her how to get it correct. I
So am
believe
I
if
being too
you'll
slow for them?
say that again.
Am I being too slow for them?
Nah. I feel like tough. Did you do pure maths or something before? I feel like he did do pure maths before. Yeah. But anyways, so Jenna,
Yes, sir.
you have 5y to the power 7. If I were to change the value for y, like, let's just say y is equal to 7x plus 1, right? What would that become? That would become 5 what?
5. Wait, what? Can you repeat what you said, please?
Okay, no problem. So I'm telling you that I'm specifying that y is equal to 7x plus 1. And so, before we do that, Jenna, we have 5. I want you to tell me what this means. What does 5y to the power 7 mean? What does that mean?
Um,
Tell me it in English.
5 multiplied by y by 7, right?
5 multiplied by y to the power 7.
Yeah, so, right, yeah.
So, like, what's the only thing being raised to the power 7?
Y.
Exactly. So, if I told you that y was, say, 7x plus 1, what would you replace y with?
7x plus 1 to the power 7.
Exactly. You would say 5 multiplied, open bracket, 7x plus 1, and that whole thing would be to what power?
To the power 7.
Yeah, to the power 7. Let's just say that y was equal to 2x plus 3. In this particular instance, what would the expression that I'm differentiating turn to?
dy dx.
No. It would turn to 5 multiplied by...
5 multiplied by 2x plus 3 to the power 7.
In both instances, is that 5 changing?
No.
No, it's something that's constant. So that's called the constant multiple rule. Like if you have a constant multiplying by a function, the constant doesn't affect the result. Like maybe I could give you another example, Jenna. What if I told you that y was equal to 9x squared plus 3? Right? 9x squared plus 3. Wouldn't that just be 5 multiplied by
And
9x squared
9x
plus 3 to the power
to the
7?
7. Yeah.
In every single instance, is that 5 changing?
No, sir.
That 5 is remaining constant because it is a constant in nature.
Yes, sir.
So if I were to ask you what the outer function is, what would you say the outer function is? Would you say it's u to the power 7 or would you say it's 5 u to the power 7?
U to the power 7.
No, it's 5 u to the power 7.
Because it's one whole function.
Exactly, and what am I putting into that? Like look at
What
this,
y
right?
is supposed to be.
I'm putting y into this.
Mm.
Look at it again. So we have 5 u to the power 7 and I'm just sticking a value for y into that.
Oh, okay.
I don't feel you fully understand that one. I feel like something's still a bit iffy. So 5 is not changing. 5 is just multiplying by y to the power 7. So like, when I ask you what the outer function is, I'm asking you, what is the function that we're putting our input into? So like, can you tell me the full function that we're putting our input into?
Yes, sir.
What's the full function we're putting our input into?
It will give you an output.
Alright, let me confusing you. Sorry.
Yeah.
Let me put back y is equal to 7x plus 1. I want you to call out in English for me what happens when I put y is equal to 7x plus 1 into this. You tell me.
5 multiplied by 7x plus 1 to the power 7.
Like that, or I have to put brackets?
Brackets, you have to use brackets.
So tell me, what am I putting into the function?
Y
Into what function?
into 5y to the power 7.
Exactly, so the outer function is actually just what?
5y to the power 7.
Well, if you want to consider it like how we was doing it, 5 e to the power 7.
Yeah.
Like,
Yeah.
you understand, like, every single instance, this is where you're changing, Like, you're putting something into here.
Okay.
In every single instance, like, okay, does the 5 ever change from being here, like, or does it
No,
always be here?
it's always there.
It's always there. So the only thing that's changing is the input over here. That's the only thing that's changing.
Okay.
Somebody says, sir, I don't. It's a composite function. Are you thinking of this as 5y to the power 7? Be honest, Jonah. Are you seeing it as 5y to the power 7?
No.
What is the only thing that's being raised to the power 7 there?
Y?
Y. So, whatever you input over here, so like, okay, the outer function is basically the whole function that you're putting something into.
Yes, sir.
So like, what I'm saying is that the outer function is 5u to the power 7 because I'm putting input into that. I'm putting an
Yes.
input into that.
Yes, sir.
I don't feel like you understand.
No,
You
I
don't make
understand.
sure you understand.
I understand. Yeah, I understand.
Like, okay, if I tell you y was equal to 3x plus 4, wouldn't I input
5.
3x plus 4 into this?
Yes. So 5 multiplied by 3x plus 4 to the power 7.
Right, so I'm putting that into 5u to the power 7,
Yes, sir.
right? And what is the inner function? What's the inner function?
3x plus 4.
Well, in that case, 3x plus 4, right? But
Yeah.
if I remember, we're not specifying, so it would just be what?
Y.
It would just be
Whatever
y.
y
Good.
is.
Yeah,
Yeah.
good. And we know that y is some function in terms of x.
Yes, sir.
Yeah. So, talk to me. Chain rule. Apply chain rule for me.
So
So remind me, it's the
35
derivative of the
derivative of
what?
the derivative of the outer function multiplied by the derivative of the inner function. So 35 y to the power 6 multiplied by dy dx.
Yeah, that's it.
Okay.
That is it. You understand?
Yes, sir.
So like when you all go into Unit 2 pure maths, this is what your teacher gonna tell you. So Jenna, remember that video where the guy Ari posed and he was just like, alright, heads, I'm gonna show you all something
Yeah.
that's
That's, yeah.
I can't say what he say.
Yeah.
But he just say differentiated like normal and slap on a dy dx to xy. I'm not sure
Mm-hmm.
if you realize, but that's essentially what we do in watch. 7 by 5 is 35, 35y to the power 6 dy dx. Like we just slap on a dy dx.
Yes, sir. I understand.
But all you actually understand now why you slap on a dy dx because it's chain rule.
Yeah. This is it. Yeah.
Yeah.
And y is actually the inner function. Y could be
Mm-hmm.
anything I'm plugging in. So whatever that is we're plugging in, we have to multiply by the derivative of that. So that's why I say in dy dx. Because y could be anything, right? So if since we don't know what it is, we know that you would have to differentiate it, so we'd say dy dx. Yeah.
Yeah. And
But like Jenna, if I told you what y was, would it be dy dx or would it be like some derivative?
If you told us what y was, then it'll be some derivative.
Because you could have differentiate that, right?
Yeah.
But if I don't tell you what y is, then it would just
Then
be
you
dy
have to use
dx.
dy dx. Yeah.
Exactly, because there's some unknown function in differentiating. All you know is that would differentiate with respect to x. That'll be dy dx. That's all you know.
Yes, sir.
So like, for all intents and purposes, I showed you all the concept. This is what you're gonna do in the exam. Differentiate is like normal. So Jenna, differentiate that like normal for me. Like how do you differentiate that? Like 5y to the power 7. Like if you didn't know anything, how do you differentiate that?
35y to the power 6.
Right? And remember, we have to multiply by the derivative of the inner function, so dy dx.
Yes, sir.
Bam. Bam. Do you all kind of actually understand implicit differentiation now?
yes, sir, for sure.
Yeah, so that is implicit differentiation.
That was pretty awesome.
And but Jenna and Virginia, are you probably like wondering, but like, sir, we had that one question where I had used product rule to differentiate x, y. I'm not sure if you all know what
Yes.
I'm talking about. Let me show
Yesterday?
you guys. Yeah,
Okay.
yesterday.
I think so.
Let me show you. Over here.
Oh, the one I solved.
Yeah. That one.
Okay.
Jenna and Virginia, do you all know why we have to use like okay, if we're differentiating implicitly, do you know why we have to differentiate using the product rule?
Because it's not composite functions. Instead, it's a function being multiplied by another one. Right?
Yeah, because this function x would like change with respect to time differently from how y would change with respect to time. So like you
Yeah.
have two different functions
That are like independent of each other.
and you're multiplying them by each other. So you have to
Yeah.
use product rule.
So if it was like division, it would have been the quotient rule.
Yeah.
Okay. Okay, sounds good.
Right, cool. So Jenna, ready to correct your homework now?
Yes, sir.
It's gonna be cake. Trust me. It's like it had to be easy. Like it's gonna be easy. It's gonna be easy. I promise you, it's gonna be easy. This is not hard. So before we go, if I give you all something like y cubed plus x squared is equal to 15, and I told you all to differentiate this implicitly with respect to x, how do you all do that? So, Jenna, what we was doing before that was implicit differentiation. So, like, tell me, Jenna,
Okay.
how would I differentiate y cubed?
3y squared.
Multiply by?
Oh, sorry. Multiply by dy dx.
Because remember, the inner function will be some function y in terms of x, right? say it, you multiply by dy dx, and then you have to differentiate x squared with respect to x. If you differentiate x squared with respect to x, what would that be?
2x multiplied by
Nah. Okay, so let me show you something, right? I gotta blow all their minds. I gotta really gonna blow all their mind, right? This will blow all their mind. If I ask you to differentiate x squared with respect to x, stay with me, right? It's gonna blow all their mind, trust. So, Jenna, same thing. What is the inner function? Okay,
x.
well, x is the inner function. What's the outer function?
U squared. So
So talk to me. How would you differentiate that? Virginia, look at this. You're gonna be mind blown. So Jenna, how would you differentiate that? Remember?
2 open bracket x squared. No. Yeah, just 2x multiplied by x
You
squared.
had to take your time. So remember, it's the derivative of the inner function.
Multiplied by 1.
How you figure that out?
Because x is the inner function and you differentiate x, which will give you 1.
But let me show this something that'll blow their mind even more. So, do I know what the function x is?
No.
So I would say dx, and I differentiating that with respect to x. Guys, what's dx over dx? What is
1.
dx over dx?
It will
1.
cancel. Oh,
Yeah. 2x by 1 is 2x. So yes, like all functions technically use chain rule. It's just that we don't typically see it. But
oh.
like remember, differentiation is asking us how one thing changes with respect to another thing. But Jenna, if like both is x, right? X changing with respect to x, wouldn't that be like a 1-to-1 ratio? Like let me explain. Like if x changed by 5, it's gonna be 5 over 5. Because can you the change in x over the change in x? If can you change in x over the change in x, wouldn't x change by the same amount?
Yes, sir.
So like, if you have the same thing over the same thing, what will it be?
1.
Exactly.
Yeah.
But like in the last example, like okay, let's do some comparisons quickly. That's dx over dx. If instead I asked you what ddx of y squared was, what would you tell me? Tell me, Jenna.
So 2y multiplied by dy dx.
Because this would now be some function y in terms of x, right?
Right, yeah.
So you'd write dy dx.
Mhm.
But this is some functions in terms of x. So that would just be dx
X,
over dx.
yeah, dx is okay. Yes, sir.
Crazy. Sounds crazy, right? So that's just simply 2x, right? X squared is just simply 2x. That's just simply 2x.
Yes, sir.
And if you differentiate 15 with respect to x, what would that be? 15 is a constant. So if I
That's
differentiate
0.
that with respect to x, that'll be, yeah, bam.
Okay.
Was that hard, Jenna?
No, sir.
So Jenna, you could now do pure maths. Unit 2 pure maths.
Oh,
That's unit 2 pure maths.
that's looking kind of crazy.
Yeah, it is. This is looking kind of crazy. By the way, guys, if you're watching this, these are my these are my students. These are my art math students now going into Form 5. I showed them Unit 2 pure math stuff, and they handled it relatively well. Right? I'm impressed. Good job, girls.
Thank you, sir.
Took me a while
So-
though, but thank you.
Nah, it's fine. Our way is to use your brain. Our way is to use all your brain. I don't want to just. All they come into my lessons. I don't gonna just teach all the things you're gonna learn in the lesson. Like, you know what I mean? Nah. Like, are they gonna learn different things here?
Yeah, that was makes it so fun.
Yeah. I'm not gonna give all the basic stuff. That's boring. Okay. So, Jenna, let's cook, right? You ready to cook?
Yes, sir.
Right, so differentiate the expression 1 plus 2x cubed by x plus 3 with respect to x, simplifying your answer. So you see now, what are the two functions there?
two functions.
They
Okay.
being added, they multiply, divided, like
Oh, the
what?
being multiplied.
So what rule are we gonna use there? Product, quotient, or
Product
chain?
rule.
Product.
Product.
Which one are you gonna say is U?
1 plus 2x.
Well, take your time. That's not the
We
you
have
didn't
to
call out the full thing from a day, you know. You didn't call out the
1
full
plus
thing.
2x cubed.
Right? And was V.
V will be x plus 3.
Yeah. By the way, girls, guess what? Guess what? Guess what?
What?
We reach 17.2. Wait.
17.3. Whoa,
Wow.
Yeah, that's
Tough.
crazy.
that's genuinely insane.
Yeah, like it is, right? All right, cool. Let's continue. So
Okay.
if you have to differentiate using the product rule, so it goes like this. So ddx of u by v
Mhm.
is just v by du dx plus what?
Plus u by dv dx.
Now in school, you might learn it the other way around. You might learn u dv dx plus v du dx. But you guys should know by now that's also correct because you know
Yeah.
addition is what?
Commutative.
Right. So that's also correct. The reason why I teach my students it like this is because in the quotient rule is v du dx minus u dv dx over v squared. I want to let's get into the habit of playing v first now. Because
Yeah.
what students the mistake students make is they go they remember the product rule and they go put u first. But if all they just remember v coming first, there's no room to make that slip up. Because all they know because okay in the quotient rule is subtraction. Is subtraction forgiven like addition?
Mhm.
Is it? Is subtraction
Oh no.
forgiving? Like how
Oh
addition is
no.
forgiving?
No, sir.
Jenna, is subtraction commutative?
Yes? Wait.
Mark, that question. What is 5 minus 7?
Negative 2.
Right? What is 7 minus 5?
2. So no,
Is
it's not.
minus 2 and 2 the same thing?
No, they're different.
Different.
But so I have a question.
Yeah?
Would chain rule be useless here, like for you, or no?
You gotta use chain rule.
Oh, we have to. Okay.
We just can't use the shortcut.
Yeah. I was just asking because I was gonna do that, and then I saw the product rule alone.
Anytime chain rule is not the main thing in the question that's being asked, you do the shorthand. So Jenna, you see how
Okay.
we have the main thing is product rule?
Yes, sir.
When you're differentiating, you just can't do the shortcut.
Okay.
So let me begin, right? So we are saying that u is equal to 1 plus 2x cubed, and we're saying that v is equal to x plus 3. So tell me, Jenna, what we find there?
Du dx. The derivative of, yeah,
And that would be equal to what?
6x squared.
Now take your time, right? Take your time. So like, okay, what is the outer function there?
Oh, u cubed.
Exactly. What's the inner function?
1 plus 2x.
Differentiate the
Wait, so we're using chain rule to figure out the product rule? Is that what we're doing? Or
Okay. So Jenna, when you do the product rule, you have the product of two different functions.
right?
These two
Oh,
different functions,
okay.
like you might have to differentiate these two functions using quotient. Like okay, if like cx was particularly wicked, then could I say 1 plus 2x cubed over 5 plus 16x, and then to differentiate this one thing, you know how to use chain and quotients and all kind of thing.
Yeah.
So like it doesn't matter, Jenna. Like the point I'm trying to make is you have a product of two very different functions.
Right.
So you can differentiate those functions however they need to be differentiated. Over here, you are seeing 1 plus 2x to what power?
To the power 3.
If you see something to the power 3, and it's a binomial in the middle, okay, I mean inside the brackets, we gonna use to differentiate that.
Product rule.
Product rule. We take a little
Rule.
zip down back memory lane. Wait, sir. Like 5x plus a to the power 9, 2y squared plus 7 to the power 5. You know, like really, anytime you have something to like a power, what do you
Oh,
use?
chain rule.
Like, let me explain. If you were to, like, okay, if you didn't want to use chain rule, what you would have had to do is, you would have to, wait, you would have had to expand this,
Right, so you don't want to do that because that takes too much
and then you
time.
would have had to simplify that, then you had to
Mhm.
differentiate that. So, Majana, anytime you see something that's a power that is more than 2, what do you use?
Differentiate it, like
Using the what?
the first derivative.
Like, which rule? Product quotient or chain?
Or chain.
Chain. Right, so, because remember, like, okay, you could clearly see here that you have an outer function u to the power 3, and what is inside that is 1 plus 2x. So this is clearly chain rule.
Yes, sir.
So differentiate that from
So 3 open bracket 1 plus 2x squared multiplied by 2,
Yep, that's it.
which is 6 open bracket 1 plus 2x squared.
Yeah. And this would be what here?
Um,
Look at the rule. So we had to find du dx. That was part of the formula. What else we had to find?
dvdx. So dvdx is equal to 1.
Yeah. Good. So now we could actually use the rule. So we want to differentiate. We want to find the derivative of uv, and to do that, we're going to say v by du dx. What's v?
v is x plus 3
We're going to multiply that by what?
by 6. No, yeah, by 6 open bracket 1 plus 2x squared.
Yeah. Mm-hmm.
And then plus 1 plus 2x cubed multiplied by 1.
Which is just what?
1 plus 2x squared. Cube. Sorry.
Right. Cool. I see anything that maybe we could pull out.
1 plus 2x. Yeah.
So what power though?
To the power 2.
Right? If I do that, what would I be left with on the inside?
1 plus 2x. Wait.
Take your time. So over here, you pull out the 1 plus 2x squared. So what would come over here?
Or x plus 3
By,
by 6.
you could expand that bracket if you
So,
want one
so
time.
sorry. 6x by 18.
6x plus 18, right?
Plus 18. Yeah.
And in the other bracket, we go have
1 plus 2x.
plus 1 plus 2x.
Yeah.
Because it would have to multiply back to give you 1 plus 2x cubed.
Oh, okay. Yes,
See
sir.
now, right? Like because this is 1 plus 2x to the power 1. So 1 plus 2x squared by 1 plus 2x to the power 1. Since you have the same base and you're multiplying, you add the powers, so that would give you to the power 3.
Okay. Yes,
You
sir.
sure
Yeah.
you understand that?
Yes, sir.
So now you could write 1 plus 2x to the power 2, and we could simplify inside the brackets. If you simplify inside the brackets, what would you get?
6 at no 8x plus 19.
8x plus 19, yeah. Because 6x plus 2x is 8x, and 18 plus 1 is 19.
Yeah.
I gotta stop here.
Okay.
If you wanted, you could expand 1 plus that's too much work. That's too much work. But like, yeah, that's fine. That's fine. I don't know if you understand that.
Yes, sir, I understand.
So Jenna, if you have a product rule question, does that mean there's no chain rule?
No.
No, because in your product rule you have to differentiate one function or like two different functions first.
Two different functions first.
Right, you might have to use chain rule for one of those functions, it may not. Are you going to do the full chain rule or are you going to do like a shortcut?
Like a shortcut.
Right. So you're going to differentiate the outer function, right? And you're going to multiply that by the derivative of the inner function.
Inner function. Yes, sir.
Virginia, you fully understand?
Yes, sir.
Right. Let's do this one.
Okay.
So Virginia, let's tackle this one.
All right.
So they want me to find the f prime x, which is the what derivative?
The first derivative.
Right, so they're telling us that f of x is equal to the square root of x minus cosine 4x. Yeah. Now before I do anything, maybe I should change up some things. I don't know. You tell me.
I guess you could probably multiply everything by 2. Oh no.
Do that. Why you do
Oh,
that? Talk to me. Why would you do that?
I mean just to cancel the square root. But maybe we could like put x to the power of a half, so you can differentiate it.
Right. Right. But you can't do that first thing. That first thing is just very illegal, eh?
Oh,
Not really legal because this is a function. If you do
oh,
that if you do that over here, you gotta do it over here, and then you got no, because that will
oh,
be f of x what squared, and then that will
oh.
be square root of x minus cosine 4x squared. What? Nah,
Never mind.
putting
Sorry.
yourself into problems.
Uh,
What you're gonna do is you're gonna convert root x to what? You're gonna get
power
rid
of
of
a
the
half.
radical.
Yeah.
Right. Um, let's get to business. If you
Okay.
differentiate x to the power half, what do you get?
A half x to the power of minus a half.
Right. I'm gonna leave the minus sign on the outside. Let's forget about that minus sign for now. I'm gonna open
Okay.
a bracket and let's differentiate cosine 4x. What rule am I going to use to differentiate cosine 4x?
I would say chain rule.
Yeah,
Oh, but I didn't
yeah,
really
simple.
see that. It's because the function 4x is in cos x. Okay.
Exactly. So like
Oh.
4x is being inputted into cosine.
Mm-hmm.
So what's the outer function there?
The outer function would be cosine
Cosine u, and what's the inner function?
4x.
Yeah.
Okay. So that would just be 4 cosine x. Wait,
Be
4
careful, you know, I'll be
cosine
real.
4x.
No,
Yeah.
take your time, take your time, take your time.
Wait, no? Oh,
So
minus.
So, wait, let me take your time, right? Let me take your time. So, take your time. So we're gonna
Wait.
differentiate the outer function. What's the outer function?
Oh, right. Minus cos 4x. So it'll be minus sine. Wait, 4 minus 4 sine x.
Wait, let me take your time, right? Let me take your time.
Okay, I go.
Right. So, Virginia, so let me figure out what is negative sign on the outside for now, right? Let's figure out
Okay.
that. We just looking at cosine 4x.
Yeah.
So Virginia, the outer function is cosine u, and the inner function is 4x.
Mm-hmm.
Let's differentiate the outer function. What would I get?
Minus sine x. No?
You're close.
Oh,
You
minus
remember,
sine 4x.
right? Because remember, you have the
Right.
inner function in the outer function, right?
Okay.
And you're gonna multiply that by what?
By 4.
Yeah.
Yeah. You know, I had that in my head, but I wasn't saying it right. I don't know what's going on. Maybe I'm tired.
That's okay. And then so like
I'm
there
not
was a
gonna lie.
minus.
Huh?
Oh wait, Jenna, you understand now or not?
No, yeah, I understand.
So what
Okay.
would this simplify to, guys?
Okay. plus 4 sine 4x.
Yeah, that's it.
Yeah. So I think I have to do another question to redeem myself. That was rather sad. Like that was
Yo,
in my head, but I wasn't saying it right. I don't know why.
thank you for the one.
Okay. Okay.
Go, go,
Okay.
go forth.
Like explain or do it.
I want you all to find DZDX.
Okay.
So, Jenna, Virginia, people on TikTok, y'all can try it. We want to find DZDX. Tough. Exponents is not in the odd math syllabus. But are really easy though. You know, like when you differentiate the exponent, you just get back to the exponent. Um, nah, it isn't. It isn't. I think it should though. I think it should, but it isn't.
So is it that we have to multiply the minus 2 by 6x and then put back the 6x?
I'm not gonna say anything.
Okay.
It's all you. When is the next physics live? I don't know. I don't know when is my next physics live. When is my next physics live? Who knows? Somebody went on my side quest page and they was like, "You're sounding like Mr. Mark vibes." That was funny. I thought that was funny.
That's like you know the interview with Mr. Bean, where like someone told him he looked just like Mr. Bean, and he was like, "I was," and no one believed him because he
Yeah.
like speaks standard English, and they were not used to it.
Yeah,
That
yeah,
was
yeah,
funny. Yeah,
yeah. Guys, this is so much easier than you all could think. I swear.
yeah. I think I'm done. I think. I hope.
Bet. Hardly anybody is who hard maths.
Yeah.
Hardly anybody is who hard maths. Like, Jenna, how much people in your class is who hard maths?
6, not including me. So 7
That
including me. That was not intentional.
6, 7,
Oh, that was not
6, 7. That's crazy. I see
yeah.
what you're doing. I see
That
what you're
wasn't
doing.
intentional.
Nah, Jenna. I know what you're doing. I know what you're doing.
Dude, that
I know you're
wasn't
up to.
intentional. I swear. I swear.
You could have just said it has 7 people, but you
I'm
have to say
sorry.
like 6, then 7. You know.
Yeah. Okay. So I feel kind of like lost, but I don't want to feel lost.
Okay, no problem.
Yeah.
The first thing you should probably do is you should probably convert cuboid to x to what before you differentiate.
X to the power of third.
That's what you do, and
Yeah, I did that. It's just the cos part mixing me up.
I swear it's real easy. I promise. I promise. I promise. I think you promise. Hear what, right? This minus two, forget about it, right? Like you are interested in differentiating the cosine 6x. This is a
Oh.
constant. The constant just multiplies by whatever you differentiate. Hear what I'm
Oh,
saying, right?
I
Like
was focusing on the minus 2, and I was like,
no.
figure that way.
Okay, when you okay, so like the constant, it's gonna
Mhm.
remain there. Like I'm not sure if you remember, but I was kind of explaining this to you over here. Where is it? Where is it? Give me a second. Like over here, I was telling you, like 5 multiplied by y to the power 7, like that 5 would always stay there. Like,
Because it's a constant.
exactly. So if you want, you could just put the minus 2 here and just differentiate your cosine 6x. And then you could multiply it back out in the end. So,
Oh,
Jenna, what is the inner function there?
cos 6x. So that would be.
No, cosine u.
Oh, sorry.
What's the outer function? Oh, sorry. What's the
Wait,
inverse?
what?
Oh. What is the outer function? Cosine u, right?
Yeah. Right.
Because,
Yeah.
okay, what are you plugging into cosine? What are you putting into cosine?
U, which is 6x.
Right, so remember, you're going to differentiate your outer function. What's the outer function?
So, minus sign,
Minus sine, and remember, you're putting the
open
inner
bracket.
function back in. So that'll be
Right.
minus
So,
sine.
minus sign, open bracket, 6x multiplied by 6.
Yep.
Okay.
And then when you finish that, you can multiply back over the minus 2. X to the power a third. How are you going to differentiate that?
A third x to the power of minus a third. Ooh, my bad. That's a third minus 1, right? Okay.
Yeah. If I had $1 for much time students, that's like one of the most common mistakes, like not gonna lie, like students can put negative at it. But
I'm sorry.
no, like I just say, like you know how like in regular maths, like one of the most common mistakes is that x plus y squared is x squared plus y squared. I feel like this is another really common mistake. Like students will just say minus a third. Yeah.
Oh.
Yeah. And nothing personal against you. I just saying it's like a common mistake.
Okay.
Yeah.
Trust in a calculator. Just saying.
A third minus 1 is
Negative 2/3.
right. Yeah. So now we could work out this. So like we have minus. Hey, another mistake students is making. Although this is not 6x by 6. No, that 6x is being inputted into a function.
The negative sign is the function, right?
Say that again?
The negative sign is the function?
No. The function is sine. Like sine is the function. Do you all know sine is a function?
That's what I said.
Yes.
Right. Guys, sine is our function. And what are we putting into the sine function?
6x.
6x, right? Now, we have sine 6x, and you multiply it by a negative sign and a 6. So what happened?
So minus 2 multiplied by 6.
Minus 2 by minus 6 is?
Minus 12.
Now, take your time. So, you're multiplying minus by sine by 6. So, on the inside, that is what? Right, so Jenna,
minus 6 sine 6x.
yeah, because you have a minus sign here, so minus
Yeah.
sine 6x. And you multiply that by minus 2.
Okay. So the minus 2 is a constant, so it's not like, it has nothing to do with the sign. Negative sign.
It's just multiplying by whatever you find the derivative to be.
Okay.
So like, if you find this to be minus 6 sine 6x, you can multiply that by this.
Oh, okay, I guess that's, I understand.
So what would you get as your final answer?
So, minus...
Nah, take it time.
No, 12 12 sine 6x. Plus a third x to the power minus 2/3.
Good. Now, I had done with all that. I feel like I need more practice.
Yes, sir.
Okay.
I want you all to differentiate 5 sine minus 2x plus 7 cosine 3x. Do that for more. Hey Romano, what's your plan? It's a bird, it's a plane. Guys, somebody asked if it's C-sec math. Should I say it is C-sec maths?
Yes, yes, I'm a bit.
Nah, I'm not so evil.
Okay. Okay,
So
okay.
this is not C-sec maths. This is C-sec art maths, additional mathematics. Yeah, which is more fun than regular maths. There, I say. This is a lot more fun. Like I would teach art maths whole day, and now you're bored. Maths is kind of boring sometimes. Sometimes regular maths.
So,
Watch out when we start. Wait, watch out when we start doing regular maths. The live number is gonna like exponentially increase. I don't know. I bet in you. I bet in you. How much on the watch out?
Yeah. I'm not even gonna doubt you, so I won't even bet. That's facts.
Yeah, Jenna, talk to me.
um, right. Almost forgot my question. This what we're doing right now, is this like how it would have been done before, or is it that we're doing it a different way because we did the shortened version, the thing?
I mean,
Like how we're using the shortened version of the chain rule to figure this out now? Is it
you're
that?
using shorthand right through. Shorthand
Oh,
right through.
so this is actually how you do it. So this is not like a shortcut or anything.
What do you mean?
Like, because you taught us how to do it, do the chain rule like a different way.
Um, this is a shortcut.
Oh,
This
okay.
is this is the shortcut we're doing. Like, this is a shortcut, and it's just like a. You come like you're just skipping a bunch of steps in a full way, and you're jumping straight to the final thing. You know, like
Okay.
the derivative of the outer by derivative of the inner. You're jumping straight to that.
So can I ask how it would look if we didn't skip?
Um, it
Or
would
is that allowed?
like the only situation where I'd recommend you do the full thing is if like you have like okay, like let me explain. If they said that y was equal to 5 sine minus 2x, if they said y was equal to 5 sine minus 2x and that was it, yeah, I'd tell you to do the full version. Because you could say that minus 2x is u, and so y would be 5 sine u, and u would be equal to minus 2x. And you would say dy du is equal to 5 cosine u, and you would say du dx is equal to minus 2. Then you would use chain rule to find for dy dx, and you would show the full working.
Oh, okay.
You understand?
Oh, okay, yeah. I've seen it now, yeah.
But like over here, it's just that we to differentiate this with respect to x and this with respect to x is like multiple things. If it's multiple things, you just do shorthand version.
Okay. Okay,
But
I understand.
I'll show you an example where we'll do the long version.
Okay.
Bam, you guys getting through?
Yes, I'm done.
All right, Jenna, talk to me. You getting through?
Kind of.
Kind
Kind
of.
of.
That's okay if you're struggling or if you need help. I here to help you.
Yeah, I think I need help.
Okay, no problem. So, did this new notation confuse you?
Yeah.
All right. If I say ddx, it just means I want you to differentiate everything here with respect to x. That's all. So,
So
like you see,
I'll rewrite ddx equals.
say that again.
Is it that I'll rewrite d over dx is equal to and then whatever?
No, you're just gonna differentiate one time. Like
Oh,
they want you to differentiate this entire thing with respect to x.
okay.
So, like they're saying, differentiate this entire thing with respect to x.
Okay.
So, like in this question, it was a bit different. Like they said that z was equal to this, and then they said differentiate z with respect to x. So, you mean you just differentiate z with respect to x. The
Yeah.
same kind of thing over here, like they're just telling you one time, I want you to differentiate this with respect to x. So, let me go. So, how would you differentiate that?
So
Well, I'm gonna put the 5 on the outside, and I'm gonna I'm gonna differentiate sine minus 2x. Let's differentiate sine minus 2x. If I differentiate sine minus 2x, what would I get?
Minus 2 sine minus 2x sine. What am I saying? Minus 2 sine x.
Take your time. So if you have sine minus 2x, right? What is the inner function?
Minus 2x.
Right? So the inner function is minus 2x. What's the outer function?
Sine.
And I'll be sine u, right?
Yeah.
Right, so remember, you differentiate in the outer and you multiply that by the derivative of the inner. So differentiate the inner, differentiate the outer for me.
Cos x.
Right, and remember, you put in the inner
Cos-
function back in.
Right, so cos minus 2x
Yeah.
multiplied by minus 2,
Mm-hmm.
which will
Right.
give you
And now let me work out the other part, which is this part over here. Then we will simplify in the end. We will simplify in the end, don't worry.
okay.
So then the other one is saying plus 7 cosine 3x. So I'm going to say plus 7, I'm going to open a bracket, and I'm going to focus on cosine 3x. How would you differentiate cosine 3x?
So minus sine open bracket 3x multiplied by 3.
Yes.
Okay.
So what that's going to be is, so like you tell me, what would that work out? What would that work out?
That'll be minus 10 cos minus 2x.
Right, that'll be minus 10
Open bracket
cosine minus 2x. Yeah. And what would this work out to be?
21 minus sine 3x
Okay.
plus 21 minus 9.
Nah. So you have positive 7 on the outside, being multiplied by minus 3 on the inside.
Oh. Okay, so negative 21.
Yeah. I still don't feel confident. I feel like we gotta do some more.
Yeah.
Let's do some more. Alright, I want you all to do this for me. Wait up, my bad. Yeah, do that for me. So Jenna, in that other question there, are we differentiating with respect to x, or are we differentiating with respect to something else?
With respect to x.
You sure?
Yes, sir.
This question?
Oh,
Right, this one over here?
oh no, in respect to L.
Right, so go ahead.
Okay.
You can do it. I know you can do it. For you are Jenna. You can do it.
Thank you, sir. Thank you, sir.
Right, Virginia, talk to me. Virginia, like everything going good?
Yeah, everything's done. Everything's going good. I'm done.
Okay, bet.
Yeah.
Oh yeah, my bell just now.
I didn't realize that was you. Like I did it. But I was like,
Oh, I should not
yeah,
say anything then.
yeah.
Should not say anything.
It's okay, sir. Don't worry, don't worry.
Virginia.
Oh my god.
You repost this.
I did. Like I forgot. I just be reposting stuff and forget it.
Bunch of dog stuff.
Yeah. All I repost is like food, dogs, edits, and tum tum.
Tum tum.
And tum tum. You know those like videos when someone's dancing next to the AI tum tum thing?
Oh
Yeah.
yeah, like What's her name? Like the Asian girl,
Yeah,
Christina, I think.
I don't know her name, but like, yeah.
Yeah, yeah, it's just Christina. Tung 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 saw her. Wait, no.
I used to be. It's not. Oh,
Okay, I swear it was. I swear it was that.
I don't know. I sent a bunch of videos like that to my friends. Let me see if I can find one. Like, say like this. I don't know if you see it.
Yeah, I know. I repost some of that too. Yeah,
Really?
yeah. I know what you're talking about.
Okay.
And like, there's like this Asian woman who's like a flight attendant. And
Yeah.
she does a lot of videos like that.
Seriously? I don't know if
You
I know
know,
her. Probably. Is that the same one that she was like something about he's into body Chinese girls and she was doing that one
nah,
dance? Not that
nah,
one.
no,
Oh,
no.
well, I don't know that.
Right. So talk to me, Jenna. How we looking? How we looking?
Yes, I'm finished.
Right. Talk to me. So what you do?
So I have minus 3, open bracket, cos minus 4L multiplied by minus 4.
Yeah, that's correct.
And then minus 2, open bracket, cos 4L multiplied by 4.
Nah, take your time. Take your time.
Oh, sorry, sine.
Nah, take your time. To
Negative
differentiate.
sine.
Yeah. Negative sign what?
Negative sine 4L multiplied by 4. So that will be 12 cos, open bracket, minus 4L plus 4 minus sine 4L.
Nah. Correct yourself. Correct yourself. Yeah. Hey, Jenna, so look at it carefully and correct yourself. You can correct. I know you can see it. You can figure it out. Figure out what was the mistake you made.
Oh, plus 4 minus sine 4L.
Nah.
No, that's the same thing I said just now. Wait, hold on. Minus 4 sine 4L.
But you multiply that by what on the outside?
Minus 2.
Right? You multiply that whole thing by minus 2. So what will you get?
Oh, minus 8.
Nah, not minus 8. Alright, so here what? When you work out the inside, you're getting what? Like,
Minus 4 sine 4L.
right? So you have minus 4 on the inside and you multiply minus 4 by on the outside.
Oh, minus 2.
Mm-hmm. So it's
So that
minus 4 by minus 2.
plus 8.
Right? So that just be 8 sine 4L.
Okay.
You feeling a little more itsy bitsy confident, like you feeling better?
Yeah, a bit, I think.
Bit. You think? Okay, you want one more for safe measure.
Yeah. Sorry.
That's okay. You know what you should be sorry for? Like if you like not taking advantage of like the extra help, but you're here and you're taking advantage of the extra help. So like
Yes.
the only people that should be ashamed is like people not putting in the work, you know.
Yes, sir.
Once a student is willing to put in the work, I'll help them. No questions asked. Um,
So making me emotional over here.
am I?
A bit.
Bruh. All right, I'll wait you to do that for me. I'm giving you 2 minutes.
Okay.
And Virginia, like the YouTube channel actually grew. Like I'm surprised.
Yeah, I feel like because you do what's the word I wanna say? Like lives every day, like daily, more or less. So
Mm.
people will share it to their friends and whatnot, and tune in religiously.
Suppose so. Like it was at 6.09. I was at 6.24.
When my brain just paused, were we talking about the viewers or the followers?
Like the followers, like it was at 6.09, and I
Hmm.
was at 6.24.
Oh, on YouTube. Oh, really?
Yeah.
Oh, that's crazy. I thought you meant on TikTok, so I was so confused. I was like, was in the 70?
Oh. Oh
Yeah.
yeah. Yeah.
And that's awesome, though.
I see like some math people from the Caribbean have like 400 viewers and thing. Like I don't know. That's crazy. That's
What? Oh,
yeah. But like, not to be prejudiced or anything, but like, I don't know like how like okay, I don't know how people like I notice like the lives kind of boring. It's like very
mm,
monotonous, and it's like
mm,
no explanations. It's just like I don't know. Like
yeah,
I think you all wanna seem like get crashing out because like like mediocre in the Caribbean is celebrated. Yeah.
yeah.
All
I mean,
right.
that's what I like about your channel. Like, you explain literally everything. So there's no
Exactly.
way to be confused.
And it'd be fun too.
Yeah, and it's really fun. All the
Mm-hmm.
memes and stuff.
Yeah. Yeah.
Yeah.
All right. So Jenna, talk to me again. True.
Yes, sir. I think I'm finished now.
You think you finished?
Yeah.
Be careful with them signs, Be careful with them
Yes, sir.
signs.
So I have -9 open bracket minus sine 2v multiplied by
Oh
2.
wait, let me just so
Sorry,
minus
sorry.
nine open bracket.
Minus sine 2v multiplied by 2. Close bracket plus 7 open bracket cos.
Wait, there you get +7 from. Take your time. That was -7.
Oh, sorry, I wrote it down wrong. My bad.
That's okay. So -7 open bracket.
-7, yeah. Yeah, -7 cos minus 6v
So like -7 open bracket.
cos
Mm-hmm.
and then open bracket minus 6v. Close bracket multiplied by 6.
Take your time. If you differentiate -6v, what would you get?
Minus 6.
Yeah.
Okay.
Right. So you're seeing a negative by 2. So what will be there?
So that'll be 18. Positive 18.
Right. Oh, bam. Yeah, you get 18, right? Negative
18.
and negative is positive, right? So,
Yeah.
yeah,
Yes.
18 sine 2v.
Sine 2v
Yeah,
plus um yeah, plus 42 cos negative 6v.
that's correct.
Okay, finally. Yes. Okay. Amazing.
That's what I know they meme Amogos.
No.
Huh?
Oh, you don't know that?
No.
Oh,
Are you serious? Hey. I, I'll just show.
Probably not, but like
like, show it. I don't.
yeah.
I feel like I know the memes, but not the names. Sometimes.
When I find the meme, I will show you. Right, but let me keep going.
Okay.
So, I gave you a lot of homework. Wow. Wow.
Oh,
Yeah. All right. So in this question, Jana, they want me to find you what?
Second derivative.
You gotta find the second derivative. So you have g of x is equal to x plus 1 to the power 4. So before you can find the second derivative, you gotta find the what?
The first derivative.
Right? Now, what rule do you think you should use to differentiate this particular function?
Chain rule.
Right. So if you differentiate that using the chain rule, what will you get?
So that will be 4 open bracket x plus 1 to the power of 3 multiplied by 1. So that will give you 4 open bracket x plus 1 to the power of 3.
Aha, but we get done yet. We gotta do now.
We have to differentiate again because we have to find the second derivative.
What would that be?
So that will be wait.
Oh yeah, look New Yorker chicken. Are they saying New Yorker chicken should sponsor my fried chicken?
yes, they should.
Yeah, I find so. Right, New Yorker.
Yeah. So you could be like a food blogger.
Yeah.
Yeah.
That'll be fun. Right, so Jenna, how am I
So
gonna find the second derivative?
that's 12 open bracket x plus 1 squared multiplied by 1,
Which is
12 open bracket x plus 1 squared.
that's it.
Wait, actually?
Yeah,
Okay. Yay.
right. Because if you differentiate this, that's 4u cubed. That'll be 12u squared, and u is x plus 1, so that'll be 12x
Yeah.
plus 1 squared by 1. Cool. Yeah, get that correct.
It actually kind of started to, like, yeah. Okay.
Sound
Yeah.
That's good. After class, you should ask ChatGPT to generate like some questions for you, or Claude, and do the questions it give you.
So, honestly, I was gonna message you and ask you to give me more questions so I could, like,
I want you guys to be self-sufficient. So like I want you all to be able to like progress without me. That makes
Oh.
sense.
I
don't
do
want you
that
guys to
for
be like
chemistry.
entirely dependent on me.
Yeah.
But so, I know what's the type of, though, like, in ChatGPT, like.
Hi, good day. I want some. I'm doing CSEC. You had to talk to AI nice. Hi ChatGPT. So, Keshav asked me. Keshav, I prefer this. I prefer I doesn't like to use this now because dot product. I doesn't like to use that to like mix it up with dot product. I just use the X. Yeah. I was saying.
Talking to AI.
Yeah.
Yeah. So, hi, good day.
You
I
sound
am
like the
doing-
KFC people. Hi, good day. What can I get for you?
So yeah. I am doing CSEC art math calculus. I would like you to give me some differentiation questions to do. That's it. You know what? I will show you what prompt I could put in to get questions.
Okay.
It's really not that hard.
Okay.
Now I do it all the time for chemistry when we're doing enthalpy. Yeah. Like I would show it my notes and ask to like generate questions.
You mean enthalpy? I just say enthalpy.
Oh, I'm probably pronouncing it wrong. That's how I had in school.
No, that's fine. Everybody's pronouncing things differently.
Okay.
Potato, same thing.
Yeah. Yeah.
All right. Okay, so Jana,
Yes, sir.
Virginia, I'm not calling you much because I feel like Virginia fine. Like Jana, I feel like Virginia. I feel like
Yeah, I feel she don't need help. Like I need help.
Okay.
free vibes.
Yeah.
Jana, what do you really think we should use for this question?
Chain,
Why? You're correct, but why?
because it has like, because like when you remove that square root, it'll become squared, so it'll be a composite function.
It wouldn't become squared. It would become to what power?
To the power of 2.
power 2.
So
Nah,
like 5x squared minus 4 to the power 2.
nah. You would be
No?
telling me that square root and square is the same thing then.
No, oh, sorry, to the power of a half. My bad.
Right. Yeah,
Yeah.
that's why you convert the radical.
Yes, sir.
By the way, this is a radical. If you don't call it a still is a radical.
Okay.
Right. If anybody watching this, and so you know that one Ravi B song, Radical, why you leave and go?
Yes.
What's your
They
name?
played that in school. I can't remember why. I think it was during Christmas. It was just
Mm,
random.
during Christmas.
Yeah. Don't worry.
Alright, so here's what. Jenna, you see how this is like the only question they're asking you, and it's like 5 marks? You think you
Yes,
should
sir.
do the shortcut, or you think you should do the full working?
Oh,
Like the
okay.
only thing they're asking in this question is strictly just chain rule. Like if it's just chain rule they're asking you,
Right, so then do
full
the
working. Like if it's like multiple chain, okay. Like you see in this question, right? How you're going to find the second derivative? You're not going to
mm-hmm.
differentiate that thing fully 2 times.
2 times, yeah. Makes sense.
Um, Brev, I would really appreciate that. Yeah, Keshav, I don't know Keshav, my good friend Keshav. Yeah, Keshav says you want me to order, pick up, and bring food for you on Wednesday. That's a friend to have. Yeah,
Yeah.
that's so
Yeah.
cute. That's so cute. Love you, bro. No homo. But yeah, yeah, yeah. Appreciate you. Appreciate you. I have some good friends and I have some good friends. Yeah, and I have some excellent students. Jenna's
Ah,
gonna cry.
yeah.
Jenna's gonna cry. Let me
Tails.
do this question.
Tails.
Yeah, so Jenna, what was the outer function?
A half. A u to the power of a half. Sorry.
Right. So we're gonna say let u be equal to
Equals
what?
it is 5x squared minus 4.
Like you see the session
And
today where like the reframe, like all they needed that reframe when
yes,
it
sir.
comes to like
Yes.
chain rule. Yeah, all they
Mm-hmm.
needed that reframe. It's a lot like it's a very important session.
Yes, sir.
Yes, I'm so glad to be a part of it.
Happy to.
I'm gonna start
no,
shedding tears.
no, that's fine. That's fine.
Okay, so y is equal to u to the power of a
Oh wait,
half.
wait. Yeah, Keshav. Yeah. Cross product. Yeah, you use this for cross product as well. Yeah, and you use this for dot product. So, I just prefer to use like a little multiply sign, you know. But you'll catch me using the dot every now and then. But yeah, Keshav, If I think I serious about maths, Keshav like even more serious about maths than me. Like,
Oh,
like, yeah, like he real serious. Like, what he doing his maths degree, he's like insane. You know, he's like insane.
Wait, so what do you do with a master's degree after? Like, become a teacher?
Academics,
Oh.
like he could be a researcher,
Mm.
and he could like research math fields to like expand, like develop new mathematical techniques. You know, solve difficult problems. You know,
oh
you
wow,
could
you do all of that?
That sounds good.
Location, I would say in data science, quant, actuary.
Ooh,
Ooh.
Yeah,
interesting.
yeah. Actuary is like risk management for businesses and whatnot.
That's like probability and statistics.
My worst
Ooh.
nightmare.
Sis
Yeah.
and
Keshav, do you like probability and stats, bro?
Watch
Do
and see what we
you,
can say. Yeah.
I feel he's gonna say no. I feel he's gonna say no. That's just it. Keshav, what do you like probability and statistics? I like probability, not stats. Valid,
And
valid.
see if you like.
If I had to pick, I'd probably pick probability too. Stats is so buns. Like
Yeah,
stats is so buns.
I don't like statistics and add maths. I did it with my teacher and I don't understand anything.
Don't
oh,
worry, that's why I'm here. You know,
Yes,
I'll,
true.
I'll
Trust in
explain
the.
it to you.
the
Right,
only time I
so
did it was in your life. Yeah.
you'll be fine, man. You'll be fine. But like probability in advanced easier than what's in statistics. Statistics in advanced easier than statistics in regular maths.
Oh.
Oh,
Yeah, it is. It
that's
is.
actually kind of shocking.
No, it is like in maths you have like cumulative frequency, you have frequency polygon, you have histogram,
Oh
You
yeah,
have
true.
line graph. You have oh god, kind of thing. But anyways, we say let u
Yeah.
is equal to 5x² minus 4, right?
Uh-huh.
And
And
we know
then
that this is let me just name it accordingly. That's the
dy
what function.
du dx.
Yeah, but we call that the what function, the inner or the outer.
Oh, the inner function.
And the outer function will be
U to the power of a
u.
half. Outer function
So this is gonna be du dx.
is equal to 10x.
Yeah.
And dy du is equal to a half u to the power of negative a half. So
Yeah.
now dy dx is equal to du multiplied by du over dx multiplied by dy du.
Yeah. What's du
So
dx?
that would be 10x multiplied by a half u to the power of negative a half. And a half by 10 is 5. X, open brackets, 5x squared minus 4 to the power of negative a half.
Yeah. Light work.
Yay.
Light work. So easy at maths. It's like maths really
I
easy.
swear, I never would have thought this easy in school.
Yeah, it's just easy. It's just like oh, this is real easy. Power of math vibes.
Yes.
Yeah.
Yes, sir.
Okay. Let's do B. No, before we do that, let me just do this question and get out of the way. This is product rule question chain. What do you think this is? Like, I didn't give you all enough time to see it properly. What do you think this is?
Product rule.
Yeah, look
That,
at product rule.
which one is you? Which one is me? Like, work fast, fast, fast.
U is
First
2x
is you.
squared plus 3. Sorry, Virginia. Sorry.
No, no, I'm sorry. You can go ahead.
Okay.
Yeah. What we
Um.
gonna do next? Speed.
So du dx is equal to 2x. I mean 4x. Yeah. And v is dv dx is equal to cos 5x. Cos 5. Cos x. Yeah.
No.
Wait. Yeah, cos 5. My bad.
Nah.
Oh.
It's chain rule.
Oh yeah. Wait. Okay, wait.
Jenna, was he in a function?
Sine.
Nah.
No. Sine is the outer function. So the inner function is 5x.
Right, because it puts in 5x into sine.
Yeah. So that's 5 open bracket cos x.
It's sure cosine x.
No, wait, that's not. Cos 5 cos open bracket 5x.
That's it.
Yeah, that's it.
Right. So let me do it like the way we are accustomed with, right? So like
Okay.
the the outer function is sine u, and the inner function is 5x. Differentiate the outer function from that.
Cos u.
And that'll be cosine 5x.
Oh, right. Okay, yeah, I seen it now.
And then
And then
multiply that by the
multiply by 5,
yeah.
which is the derivative of the inner function. Outer function. Inner function, yeah.
Right.
Okay.
And
Just,
how the product rules go again?
um, d over dx.
Mm-hmm.
I know it
Somebody
just.
say wait. Somebody said just use AI. Just use AI to brush your teeth. Just use AI to bathe.
How you say
Yeah.
AI and like. Right, yeah. So
Mm-hmm.
again, that's it. Just give me a second. um, so 4x multiplied by 5 cos 5x.
So remember, it's v du dx plus u dv dx.
Product rule, right? Okay. So sine 5x multiplied by 4x plus 4x multiplied by sine 5x.
Remember, take your time. So it's v du dx plus u dv dx. So what's u?
Or 2x squared plus 3 multiplied by sine 5x. My God. So that'll be 4 sine 5.
Let run back again. So
Okay.
I make a mistake. So it's v du dx, u dv dx. What's dv dx?
dv dx is 5 cos 5x.
Yeah. So you could write it as
So that'll be 4
4x.
sine 4x sine 5x plus.
I can't tell them take this. I can't tell them. I can't leave it like this.
Oh,
If you want, you could expand the brackets, but this is fine.
okay.
Yeah.
Wait, so just at the beginning we did chain rule.
You know why we did chain rule?
Because it was product rule. Like,
No, like it could have a product rule question and you don't know how to use chain rule.
it's like at the tip of my tongue. I just don't know how to say it.
Like why? Okay, so like the instances where we use chain rule is if you have something to like a weird power, like 3, a composite function. Like you see in for yourself, right? Like you have 5x inside sine.
okay,
Like okay, I don't feel you understand now. I run it back again. What is the what's the outer function?
sine
What you put it into that?
5x.
So you have 5x, which is a function of x, inside sine. So you have a function in a function. So that's a composite function.
So you differentiate the outer function, so that'll be cos. Then you put back the inner function, which is 5x, and then you differentiate the inner function, which is 5.
Right.
To multiply by 5.
And so like if you see something like, let's just say you see something like 1 plus 2x to the power 7, where you use the differentiator.
Chain rule, because it's
If you see something like cosine 7x, where you use the differentiator.
chain rule.
Exactly. Anytime you see a composite function, you use chain rule.
Okay. I think sometimes but when I don't see the brackets, I just get kind of confuzzled.
Oh. Practice.
Yes, sir.
Cool. Are you okay with this?
Yes, sir.
So here I was saying, if you see a product rule question, you may or may not have to use chain rule. It depends on what the function for u and v is.
Okay.
You understand what I'm saying by that or not?
Yes, sir. I think so.
Okay, if I had 2x squared plus 3 by 7x plus 8.
Well, you'd have to differentiate that because it's to a word power.
So again,
You have to use chain rule to
I wouldn't use chain rule.
know for like the 2x squared plus 3.
No, you're not gonna use chain rule for that. Where did I use chain rule?
You just differentiated it.
I just differentiated like, okay, if it was like 2x squared, if the entire thing was being raised to like the power 7 or something.
Then you use chain rule.
Yeah, because like no, yeah, the outer function is usually power 7 and you put in 2x squared plus 3 into it.
Okay.
I
Okay.
feel like it's a little, I feel like you're, like, not fully. Again, the vibe that is like not fully.
I kind of.
Okay, what I'm saying is, in product rule, it don't necessarily have to be that you had to use chain rule. It just depends on what the what the function for u and v are. So like in this case was u. What is u?
2x squared plus 3.
Are you going to use chain rule to differentiate that?
No, because it's easy to differentiate.
Besides, it's easy to differentiate.
It's not a big power.
Besides that, you're not seeing a composite function.
Oh, no, sir.
Like okay. If you look at sine 5x, what are you putting into the sine function?
5x.
Exactly. So there's a you would use chain rule.
Chain rule, okay. Oh, right.
If you had
Oh,
something like 2x squared plus 3 to the power 9, then
then you
you
would
would
use,
be
yeah.
exactly because what is the outer function there in that instance?
Sorry? The outer
Was
function
the
is
out
9. U to the power 9.
and the inner function is
2x squared plus 3.
yeah.
Okay, I understand.
But this is just 2x squared plus 3 though. That you can
Yeah,
differentiate that.
okay.
Cool. Right. So Virginia, I could tackle this question in the meantime. But Jenna, I'll wait to get the question. I'll read from it.
The point P18 lies on the curve with the equation y equals 2x, x plus 1 squared. Determine the equation of the normal to the curve at point P.
You know what to do for this kind of question?
No, not really.
Nah.
When I
All right.
see the equation of the normal, I kind of start to,
It's like nah.
yeah,
All right. When you find the derivative, you find the gradient at the what? You'll be finding the gradient at the what?
of the tangent.
Exactly. Exactly right. Exactly.
Okay.
Like in regular maths, you know, you'll learn that if you want to find ingredients at a point, you would just draw what's at that point.
A tangent,
Right.
like a,
And you would take 2 points along it, and you know you'd find that gradient. So
yes, sir.
when you find the derivative at a point, you're really finding the gradient at the what? At that point. Well, you're really finding the gradient at the what?
Gradient of the tangent.
Yeah, you're really finding the gradient at the tangent. Cool. So keep that in mind. So this this is the tangent. Now the relationship between the tangent and the normal is that the normal is perpendicular to the tangent. You
Okay.
understand?
Yes, sir.
And so what would the angle between the tangent and the normal be?
90 degrees. A right angle.
Yeah, a right angle. Now, if you have lines that are perpendicular to each other, what relationship would the gradients have? They be the what of each other.
It equal. The,
That would
like,
now think about that. That would make sense because
wait.
if it's the same gradients, that would mean that they're parallel. But these clearly not parallel. Think about it.
Oh, so the equation. Wait, what are you asking? What's the question?
If you have two lines that are perpendicular to each other, how are the gradient? How is the gradients? What's the relationship between the gradients?
0.
Nah. Nah. Alright, let me help you.
Um,
So if two lines are perpendicular to each other, then the gradients are the negative reciprocal of each other. So like let me explain. If the gradient of this tangent was say negative at 2, right? I would
oh,
change that sign
if
and I
separate.
would flip it.
So 3.
Yeah,
So
the
the
three
coefficient
coefficient. Nah. We mean coefficient.
Is there another word for that? The reciprocal? Like when you
Nah.
flip something like that and change the sign?
Nah, it's literally the negative reciprocal.
Oh, okay.
Yeah. So the gradients are the negative reciprocal of each other.
Okay.
So like you're probably wondering, but still how you gonna use that in this question? Well, when you find the first derivative and you put in the x value at that point, where you finding at that point?
The equation of the normal.
Now you're finding the gradient of the tangent. So you take some notes. When you find dy dx, when you find dy dx, what you're really doing is you're finding the gradient of the tangent. At at Alright, like okay, think about this, right? dy over dx. Now this is a oversimplification. This is a gross oversimplification. But you can think about it like this: dy is the change in y over the change in x. What formula that sounds like? Change in y over change in x. Tell me, Jana, what formula does that sound like? Change in y over change in x.
Equation of the line, is it?
Nah, that's the formula for gradients.
Is y squared minus y1 over x squared minus x1?
Nah, the equation, okay, the formula for gradient is y2 minus y1 over x2 minus x1. No y squared.
Oh, wait, what did I say? Y squared?
It's a y squared on
Oh,
x1.
sorry. No, I meant y2. Sorry.
Okay, good, yeah. So y2 minus y1 means you change in y, and x2 minus x1 means you change in x.
Yes, sir.
So dy dx actually means the same thing more or less. Dy over dx. You can think of it like gradient because change in y over change in x
Is the same thing as the gradient of the line.
but specifically the gradient of the tangent.
Yeah.
Like again, if I ask you to find a gradient, if I ask you to find a gradient at this point over here, what you would do in regular maths is you would draw a tangent to that point and you would take 2 points and you'd find a gradient. But
Okay.
when you differentiate, you're actually finding the exact gradient at this point. And so when you differentiate, you're finding the gradient of the
Normal.
no the
Tangent.
tangent.
Tangent. Tangent. Okay.
Tangent. So when you differentiate, you're finding the gradient of the tangent.
Okay. Yes, sir.
Right? So when you differentiate, you're finding the gradient of the
Tangents.
cool. So in this question, they say you have a point P18 and it lies on the curve with equation y is equal to 2x by x plus 1 squared. Okay. And they want us to determine the equation of normal to the curve at the point P. So first things first, if you have to find the equation of the normal, first things first, like the normal, that's the equation of a what? The normal is the equation of a what? The normal is a curve, a line, what is it?
A line.
A line. So a line takes the form of y is equal to mx plus c.
Yes, sir.
So what I need to figure out is the gradient of the normal, because I'm trying to figure out the equation of the normal. So I need to find the gradient of the normal. So I need to find the gradient of the normal, and I need to figure out a point on the line. And let me explain, right? Let me explain. Jana, if you have a point on the line, right? That means you have an x value and you have a y value. And if you have the gradient, what's the only unknown?
Y. No, C. Sorry. C.
C, so you can find for C, right? And that
Yeah.
complete the equation. So cool. So the first thing I gotta do is find gradient of the normal. I see. So the first thing you have to do is find ingredient at the tangent. How are you going to find ingredient at the tangent?
Differentiate
Right, differentiate.
y.
With
So
respect to?
which is vector x.
Right, now let me explain something. How you want to differentiate this?
I would say product rule.
Right. Virginia, do we have to use product rule to differentiate that?
Chain rule.
I think so. Oh
Nah.
no.
Nah.
Oh,
Because, okay, let me
wait,
think, right?
because
Let me think. So it's something to the power 2. If it's to the power 2, could you easily. Okay, would that be hard to expand?
no.
No.
That would be really easy to
So we
expand, right?
just expand it and multiply by 2x.
Yes. Or you
Oh,
could do product rule, which is overkill.
Uh,
Wow. Right? So, Jana, if you have something like to the power 2, you could expand it and simplify and then differentiate.
okay.
So, Jana, what is x plus 1 to the power 2?
X plus 1 by x plus 1.
And what will they get?
X squared plus 2x plus 1.
And we're going to multiply that whole thing by 2x. So, what would you get?
2x cubed plus 4x squared plus 2x.
Yeah.
Oh,
And now we could easily differentiate that. Really easy to differentiate.
so dy dx is equal to 6x squared plus 8x plus 2.
And we want to find the gradient at what value for x. Remember guys, remember something, right? The gradient for a curve, does it remain the same everywhere?
no, sir.
No, it's constantly changing.
Yeah.
So we have to find the gradient at a specific value for x. So Jenna, what's the specific value for x they gave us?
1. So you substitute that into dy dx.
And when you do that, you'll be finding the gradient for the what at that point.
The tangents
Yeah.
at a specific point.
And what would you get?
6 plus 8 plus 2.
Right, so that is 16.
Yes.
So what I mean, that tells us that the gradient at the, it's like, I'm gonna draw the graph here, right? Draw the graph so you can kind of visualize what happening. I think that might help out a bit. Let's see what happened on the graph. So you have a function, y is equal to 2x by x plus 1 squared. Right, so you see that's a cubic equation.
Yes, sir.
And they give you a point. That point was what?
118.
Right, so you can see that that point is on the graph. That point is on the graph.
Yes, sir.
Right, that point is on the graph. Nice. Cool. And so what we just found was a gradient for the tangent at that point.
We have to find the gradient for the normal.
Exactly.
Well, yeah.
So how would I use this to find a gradient at the normal?
Substitute it into the formula y equals mx plus c.
No.
No.
Talk to me. What's the relationship between the gradient at the tangent and the gradient at the normal? What's our relationship?
Oh,
What?
you flip it.
You flip it, and you don't just
Because
flip
it's
it, you also do what?
perpendicular and change the sign.
Exactly. So if the gradient at the tangent is 16, what would the gradient at the normal be?
Negative 1 over 16. Negative 1 over 16.
Good, because this is actually 16 over 1.
Yes, sir.
Good, so you have the gradient at the normal now. Do you have a point on the normal?
Yes, sir.
If you're confused about it, read the last part of the question and it will make sense. I'll wait to read the last part of the question.
Determine the equation of the normal to the curve at point P.
At what point?
Point P, which is
Do
what
we know what point P is?
yes, sir.
Oh, so like here we're gonna do now, right? Once you have the gradient, you're in a good space. You're in a good space of mind. So you have the gradient at the normal, and you know that the equation of a line is y is equal to mx plus c. I think my Apple Pencil just died.
Oh,
Did it die? Look, Mrs. Martin is on me. It's done 0%. Yeah, at a charge. Yeah. Alright, I'll let charge of it. It's so depressing. Hardly have any viewers. Sad. Yeah, boy. Nobody's who had maths. Yeah.
glory, sir. At least we're here.
At least you guys are here. I appreciate you all. Alright, I'm gonna give my Apple Pencil. Wait, but in the meantime, though, Jenna, I want you to try to finish it. See if you can properly figure it. Finish it. So you know
Okay.
that the gradient of the normal is minus 1 over 16. And you know you have a point. Hmm. Figure out what to do next.
Um, okay.
You want me to teach Devon modular arithmetic? Okay, I suppose I could do that. I'll ask him if he's interested in that. It's like I really like to do higher level maths, something like deep maths. But it's like beautiful discouraging when like hardly anybody watching is like depressing. It's like people in the Caribbean, so upsetting. Yeah,
Yes, sir. I would send it to my friends, but they would be like, "It's vacation." So,
yeah, yeah.
yeah.
Ooh. I feel like the reason why people in the Caribbean generally really struggle with maths is their mindset towards it. Because like you'll see like foreign creators doing lives like this, and like what's saying yeah, foreign is like people living away, right? Yeah, yeah, foreign is away. Yeah, and you'll see like lots of viewers, but like the Caribbean just has such a negative mindset towards math. They wouldn't open like they like mind towards it. Depressing.
Well, that's why we have math vibes for the future of the Caribbean, to change people's hearts. Yeah.
Yeah.
6, 7.
Why do I see this number more than I see my sister?
Oh my, oh my. Honestly, same.
You know what? I see this TED talk today, and it was like success. It's like a tough journey, but you'll never know if you could succeed if you never start, and you gotta like keep going. That's like well, and that'll stay with me because like think about it, you wouldn't know if we're gonna do is gonna be successful unless you start.
Yeah, I understand that.
So you gotta
And
start
I
somewhere.
remember, I remember from primary school, there was like this quote from Dr. Ben Carson, a neurosurgeon. He was like, treat failures as a hurdle because it will strengthen you for your next success. Because if you never
Yeah,
had failure, you would never succeed because you wouldn't know where your mistakes lie, if that makes sense.
exactly.
Yeah.
Like when I made that mistake in class, and like I was like I do some like discovery, I just like mess around and I figure it out, and I come back here to like show you the proper thing.
Yeah, that was awesome.
So you know when you don't understand something and you get so frustrated?
Mm-hmm.
That's how I feel right now. And what you said just now kind of, you know,
All right,
jumpstart.
take your time. You'll get through. So,
Yeah. No, I have to answer.
like, I promise, Jenna. Like, are you willing to see how easy this is? Like, I promise you. Like, it's
Yes,
easier
sir.
than you think. So, we need to find the equation of the normal. Now, we know that the equation of the normal is a line.
Yes, sir.
What's the equation of a line?
Y equals mx plus c.
Do we
So
know
you
what m is?
values,
Say that again?
substitute the values into the y
Yeah.
equals mx plus c.
Yep. Do you know what m is?
M is, yeah, so negative 1 over 16.
Right? Do you know what x and y is?
Yes, sir.
What is x?
X is 1 and y is 8.
So that would allow you to find for what? Like when you plug in everything, that would allow you to find for what?
C.
Right. And once you have c, you could write the final equation with m and c in it. And that's it.
Okay.
Is it that you had figured out, but you wasn't sure if it was correct?
Yeah, yeah.
I'm gonna be honest with you. Sometimes I just had to take a risk, you know. Like if it making sense in your head, chances are it might be right. So you had to take a risk. Yeah, you had to take that risk.
Okay. So I think this was the night that I had watched this live and the stationary points that I did during class.
Mm-hmm.
So I have watched the video recording at home, but I got my answer though.
All
I
right.
think.
So let me check it out. So y is 8,
Hmm.
m is minus 1 over 16,
Yeah.
x is 1. So you're gonna get minus 1 over 16 plus c.
So you have to move
So,
this out.
mm-hmm. So 8 plus 1 over 16.
Is equal to C, and that'll be 129 over 16.
Yeah.
So then that's y is equal to minus 1 over 16x plus 129 over 16.
All right. This is the time to show. Like you want to, you know what they say, seeing is believing, right? So you want to see if your answer correct.
Sure, yes, sir.
All right, bet. Now, if your answer is correct, first of all, the line must pass through what point?
The
Intersection point.
Dr.
The,
Majana,
oh, sorry.
you you figured out the equation around what point? What point?
oh, 0.18.
Right. So if you use 1/8 to figure out what C was, then you know what point that line had to pass through.
The
Had to pass through 1/8.
right, yeah.
Had to
Oh,
pass through 1/8. Right.
yes, sir.
So because I mean you use that together with the gradient to find for C. So that means 1/8 has to fall in that line.
Oh, oh, okay. Yes, sir.
Because it said they said find the normal at, I mean to the curve at point P. At point P.
Okay.
So let me see. So like if I'm correct, that line supposed to cut through what point?
1/8.
Let me see. This is the moment. I think it will work.
I hope so.
Yes. I'm like 100%
Um,
confident.
look at that. You
Mm,
see?
yes,
Wow.
sir. So
Now,
that's the normal.
yeah. So
Okay.
the tangent supposed to be what to that.
Um, perpendicular.
So let me find the equation of the tangent now. So
Oh,
the tangent is gonna pass through that same point. The only difference is it have a different gradient. So tell me,
okay.
Jenna, how would I find the equation of the tangent?
Um, I'm not sure.
Nah, you know it. It's in there.
Um,
The tangent is our what? What's the tangent? What is the tangent? A
Or
curve, a line, what is it?
the line.
All lines have what general form?
A gradient.
Yeah, but what's the form? What's the equation of a line? What's the equation of a line?
Or y equals mx plus c.
Right? What do you need to be able to figure out C?
But the gradient.
Yeah, you need a gradient, and what else you need to find for C?
X and y.
Mm-hmm. Do we have those already?
Yes, sir.
What's that?
Y equals. Is it not the same thing as the equation of the normal?
No, we're trying to find the equation of the tangent.
Oh.
If we're trying to find the equation of the tangent, you wouldn't use the minus 1 over 16, you'd use the 16 over 1.
Oh. Oh, because the right, okay, because the normal is perpendicular to the tangent. Do you flip it?
No, okay, remember when you differentiate, and you plug in your value for x, that is given the tangent. So we already had the tangent, so the gradient of the tangent was what?
16.
Yeah, and I actually had to flip that to get the gradient of the normal.
Oh. Oh. So 16x plus 129 over
That
16
no, no,
minus.
no. Those two lines
Oh.
are gonna have completely different y-intercepts.
Oh.
Here's what, right, Jonah? The only thing you know for sure is that the tangent and the normal it passing through that same point, 1/8. So if you know it passing through 1/8 and the gradient is 16, how you could find for C?
Like you move it to the next side.
Uh, Take your
Wait,
time.
what was your question? Can you repeat it, please?
So, do we have the gradient of the tangent?
Yes, sir.
What's the gradient of the tangent?
16.
We have that. Do we know what y and x is?
Yes, sir. So you just
So,
substitute values.
exactly. So, like, if you realize it's the exact same process, like how we find the
Yeah.
equation of the normal is literally the exact same process. You're just using the other gradient. Alright? So, what's y?
Y is 8.
Mm-hmm. What is m?
16.
Yeah. What is x?
1.
So we're gonna get 16 by 1, which is 16, and we can move that across one time. So that'll be 8
Mm-hmm.
minus 16 is equal to c. And so c would be equal to
Negative
what?
is equal to C. Negative 8.
Yeah. So what's your final equation on the tangent?
So y is equal to 16x minus 8.
So if we're correct, that line is supposed to pass through what point?
0.18.
And it's supposed to be what to the normal we just draw?
Perpendicular to the normal.
Let me see. This is the moment of truth. So y is equal to 16x. Bam, look at that.
Okay. That's cool.
Yeah. But you see, like, both of them gonna have completely different y-intercepts. Why? Because, like, Jenna, okay, do you know what the y-intercept is?
Yes, sir. It's where the line cuts the y-axis.
Now, think about it logically. These two lines, do they go in the same direction?
No.
No. And they go in, like, both of them going in completely different directions, right?
Yeah.
Because they are perpendicular to each other. Think
Yeah.
about it logically. If two of them are going in completely different directions, do you think they would share the same y-intercept?
No. Different
Nah,
y-axis.
because like remember they're going in different directions, right? So
Yeah.
like maybe the normal might cut the y-axis somewhere. Like in this instance, it's cutting it here,
Oh, okay.
and the red line would cut the y-axis over there. The point I'm
Mm,
trying to make is because both of them going in different directions, they're gonna cut the y-axis at different places.
okay.
So like when you told me that C is 129 over 16, I say nah, that's why.
Mm.
You
Okay.
understand that one?
Yeah. Yes, sir. I understand.
Explain it to me then. Let's see, explain it to me then.
So the equation of the tangent will not cut the equation of the normal because they're both going in different directions. Also
Now,
because they're perpendicular.
I feel like in your head, you know what to say, but you're saying the wrong thing. You just
Oh.
said that they would intersect the equation of the normal or something. Take your time. Say it back.
The equation of the normal of the tangents would
Mm-hmm.
not intercept the equation of the normal.
No, would not. Nah, nah. We are
It would?
comparing y-intercepts. So, what I'm saying is, the equation of the normal and the equation of the tangent would cut the y-axis at different points because both of them going in completely different directions.
Oh. Oh, okay.
Like, okay, the red one going in this direction and the blue one going in this direction. So the blue one end up cutting the y-axis at 8.0625, and the red line end up cutting the y-axis at -8.
Okay.
So say
Yes.
it, come on now.
So the blue line would cut the y-axis at a different point from the red line
Why?
because they're both going in different directions.
Exactly. But both of them passing through what point?
To the point 1, 8.
Exactly.
But because they're going in different directions, they would cut the y-axis at different points.
Yeah.
Okay.
Let's just summarize. When you find the first derivative, you find an ingredient of the what?
The gradient of the tangent.
You find an ingredient of the tangent. To find a gradient of the normal, you actually have to find the negative reciprocal.
Okay.
You sure you remember that?
Yes, sir.
Jenna, you be completely honest, you know.
I think if I try another one, then I'll start to stick. But I think I understand what you're saying.
You're sure?
Yes, sir.
I'll give you all a worksheet with solutions.
Okay.
Alright? So Jenna, let me just do a quick recap. If they ask you to find the equation of the tangent, what are you gonna do? What's like the general steps you would follow?
So you have to differentiate the gradient of the tangent. You have to differentiate first derivative and then substitute those values into
Do you said those values. When
the
you differentiate,
substitute the points that they give us.
now when you differentiate, are you plugging in the y value too? Or are
No,
you
just
plugging
the
in just the x, right? Just the
yeah.
x? Mm-hmm. Yeah.
So yeah, so you substitute the x values into the equation,
Into the first derivative,
into the first derivative. Sorry,
and that would give you the gradient of the what?
normal,
Now,
which is no.
that would give you the gradient of the tangent. Alright, so remember, when you find the first derivative and you put in the value for x, you find a gradient of the tangent at that point.
Okay. Oh, okay. Yes, sir. Yes, sir.
So when you find the first derivative, you're gonna get the gradient of the what?
Tangent.
Correct. Gonna get the gradient of the tangent.
And to find the gradient of the normal, then you put in the negative reciprocal of the tangent.
And all that means in English is just flip it and change the sign. That's
Yeah.
all.
Yes, sir.
And both the equation of the normal and the tangent, they are what? Curves or straight lines?
Straight lines.
Yeah. And all straight lines have what form?
Perpendicular to each other, so
Nah.
they don't intersect each other.
Nah. They do actually intersect each other, you know. Like they intersect each other at this point.
Like they don't run in the same direction.
Alright. When I ask you for the general form, I'm talking about y is equal to mx plus c.
Oh, okay.
So The normal and the tangent would both be lines, so they would have what equation? Like what general form?
Y equals mx plus c.
Y is equal to mx plus c. You would have the gradients. Let me just say find the gradient of the tangent, right? You would plug in the gradient of the tangent. You would plug in a point, and that would all the way to find for what?
Find for the equation of the normal using the
Nah.
negative reciprocal.
Um. Alright. Here I ask, right? Now you're running back again. If you wanted to find the equation of the tangent, you would find the first derivative. You would plug in the value for x,
Yes, sir.
and that would give you the gradient of the tangent. Now, using the gradient, right? Using the gradient, and what else? What would I use to find for c?
And the y values. The gradient and the x and y values, which is
Yes.
the point that
Right. Point. You make c the subject of the formula, and
Mhm.
here you write your final answer.
Yes, sir.
Right. Now, if you had to find the gradient of the normal, well, after finding the gradient of the tangent, you'd have to change the sign for that and flip it.
Yes, sir.
And you'd use the same point. You'd use the
Okay.
same point as the tangent.
Yes, sir.
Because like the tangent and the normal just pass through the same point. Check it out.
Okay.
Like watch. Look at the red line and the blue line. What do both of them pass through?
The same line,
Same point.
same
Yeah?
point. So, yeah.
Both of them pass through the same point. So remember that.
Yes,
So
sir.
I'll send you this note, and I'm gonna see if I can do a worksheet for you now, and I'll send it in a group chat.
Okay.
And it will have solutions at the end too.
Yes, sir.
Right? But I'm gonna call it a night there, guys. Um it's 10:43, right? I finished earlier. But guys, big up all yourself, all your help in the work and thing. I feel like I'll understand children a little better,
Definitely.
right? So that's the most important thing. Alright, but I will make a worksheet and I will send it to you guys.